Hi, this is Anita Gale. I'm CEO of the National Space Society. It's a pleasure to have you join us for the 2021 International Space Development Conference. All virtual this year, at least we have content for you and programming for you. We hope you enjoy it, and we'll see you next year in Arlington, Virginia. Thank you.
Dear Earth, we're sorry for all the things we've done to you. We're sorry for coal plants, oil spills, nuclear waste, dirty factories, auto emissions, wildfires, and climate change. We really didn't understand. We didn't mean to hurt you, but our needs got the best of us. Now we know there's a better way, one that will give us everything we need without harming you ever again. Can we start over? We have a new plan, and we really mean it this time. We promise. It's all about electricity. We know, we've tried that before. Coal, oil, gas. Those were the choices for a different time. But we promise to do better because we have a new source of power at our fingertips. Space solar power. The sun provides clean and virtually limitless power 24 hours a day. It is a huge, inexhaustible source of energy that will be kind to you, Mother Earth. The ways we currently harness solar power are a great start, but only provide energy for part of the day and are limited by weather and other conditions here on Earth. And your atmosphere, while we cherish it, reflects about a third of the sun's energy back into space. Solar power generated in space and sent back to Earth frees us from these limitations and will allow us to provide virtually unlimited amounts of energy to the entire planet, night and day. Space solar power is clean, abundant, and the costs of collecting and transmitting it back to you, dear Earth, are negligible. And space solar power is virtually emissions-free and kind to you. We have the rockets and the proven technology we need to start building space solar power now. We may even be able to utilize the resources of your neighbor, the Moon, to build these orbiting power stations. We really want to do the right thing, Mother Earth. We're ready if you are. Space solar power will help us to repair the climate and make you healthier than ever. So what do you say, Earth? Ready to give us a second chance? Space solar power is the answer. To learn more and donate, go to go.nss.org/SSP.
Welcome, everyone, to the National Space Society's International Space Development Conference 2021. We are virtual this year and are delighted that you are joining us today. We look forward to seeing you in person in 2022 in National Landing, Virginia, near Washington, D.C. The National Space Society is committed to bringing together the best and most brilliant minds who are not only envisioning humanity's migration into space, but making it a reality. Today, I am honored to be presenting the National Space Society's Space Pioneer Award for Historic Space Achievement. The annual Space Pioneer Awards recognize those who have helped to open the space frontier and who have made significant contributions in different fields of endeavor to develop a spacefaring civilization that will establish communities beyond the Earth. Allow me to introduce you to the incomparable Dr. Peggy Whitson, groundbreaking, record-setting, trailblazing, space-blazing, space ninja, and female role model, astronaut Peggy Whitson. Hailing from Mount Ayr, Iowa, Peggy has her doctorate in biochemistry, has worked as a NASA research biochemist was a member of the U.S. and USSR Joint Working Group in Space Medicine and Biology. In 2003, she served as commander of the 5th NASA Extreme Environment Mission Operations, or NEMO mission, and was the first female commander of the International Space Station. Astronaut Whitson holds the record among all, and I mean all, American astronauts for spending the most cumulative time, 665 days in space, and has conducted 10 spacewalks, which has earned her a place on the Space Endurance List. Her list of awards and accolades is long and impressive, so here are just a few highlights. Astronaut Whitson is the recipient of the American Astronautical Society's Randall Lovelace II Award, a NASA Outstanding Leadership Medal, a NASA Spaceflight Medal, a Distinguished Alumni Award from Rice University, a Russian Medal of Merit for Space, and has been inducted into the Iowa Aviation Hall of Fame. Today, the National Space Society would like to bestow the honor of the Space Pioneer Award for Historic Space Achievement to you, Dr. Peggy Whitson. Thank you for your legacy. What you have achieved is etched into the fabric of space history, and all that you have done will inspire for decades to come. You have gone before, pioneer that you are, and proved that there is indeed a place for not only women, but anyone who dares to dream of being in space and living among the stars. So, to the moon and Mars, future space explorers will surely go. We thank you for pushing us ever onward and upward. Welcome, astronaut Peggy Whitson. How are you?
I'm fantastic. I am so honored to get this award. It means so much to me. It's very special. And, you know, lots of impressive folks have received this before. And so I feel very humbled by that. And thank you very much for your very, very kind words.
Oh, you know what? I have been a fan of yours for a super long time. So the privilege to just meet you is all mine today. And I want to tell you about, there was a moment several years ago, and it was early morning. The news is playing, and here comes astronaut Peggy Whitson with a note to herself. And it was about 5 minutes long. My husband's crying. I'm crying by the end of the thing. It was such a powerful message, and perfect for that day upon which I heard it. But here's what I recall. You are talking about growing up on a farm. So I want you to share with everyone about how growing up on the farm really kind of shaped you, and how, you know, prepared you for being an astronaut.
Well, I really do think it was important training for me, in the sense that I had to learn determination and hard work. My parents are probably the hardest working people I've ever met. You know, they always had the job to do. And even if it seemed impossible to me, they always managed to accomplish it. And, you know, so I think that was a good characteristics to pick up, you know, this dedication, this, you know, determination to achieve your goals and to make things happen. And so I think growing up on a farm was very important. My dad was great at fixing things, which turned out to be a very good talent to try and develop as I grew into being a space station crew member, because you're always having to fix something on board the space station.
Well, I also recall, though, did your dad take pilot lessons first, and then you took pilot lessons? How did that go?
So when I was 10, he learned to fly a plane, and it was just, you know, a little 150 Cessna, and I got my very first ride in an airplane. And of course, I was totally enthralled by that. And I wanted to learn to fly too, but of course, you know, we lived on a farm. We didn't have a lot of extra money. And so I sold chickens until I could make enough money to get my own flying lessons. So it was 10 years later. It took a little while, a lot of chickens.
So anybody out there listening, if you want it badly enough, you can always sell chickens or something to make that dream a reality. I just love the story. And I guess another reason that I know that the farm had profound effects on you, you also said in that same broadcast that it wasn't lost on you that while you were growing plants on the ISS, your dad was below growing vegetables on the farm.
Yeah, actually, he was growing soybeans and I was actually growing soybeans. So we were both growing soybeans at the same time. I only had like half a dozen plants, but compared to his several hundred acres. But
still, it's a beautiful sort of as above, so below moment. But tell everybody, becoming an astronaut, I mean, didn't happen overnight. Certainly, you were already working at NASA in biochemistry, but talk to everybody about that process. I think when they hear how arduous and how maybe dedicated to that dream you must be, it's a good lesson for us all.
Yes, so I had wanted to be an astronaut since I was 9 years old. When I first saw Neil Armstrong and Buzz Aldrin walk on the moon, it made an impression on me. But I think it went from being a dream to a goal when NASA selected the first female astronauts when I graduated from high school. That's when it seemed, okay, it's real. I can do this. You know, I was maybe naive about how easy that would be to do. Very naive, as it turns out. After I got my PhD in biochemistry, I started applying to become an astronaut, and I was working at NASA at the same time. And I just was not, you know, I didn't even get a call for an interview or anything for 10 years of applying. So every couple of years, they'd have a new application cycle, and I would apply over and over again. But in retrospect, I can look back now and say those 10 years are the 10 years where I learned a lot about teamwork, working together in small teams, leadership, international relations. Those are all the things that I think made me suited to be selected to be a commander on the International Space Station, and then later selected to be the chief of the astronaut office. Both happened to be first for women. And as chief of the astronaut office, I thought it was even more impressive that I was the first non-military person to serve in that role. I think that was kind of more of a shocker factor for most of the folks in the office. The astronaut office is about 50% civilian versus military, and so they had never had the experience of what's a civilian gonna be like. The military guys were all worried about it, I think, but it worked out fine. But those 10 years, in other words, ended up being the right thing for me, even though I was very impatient at the time and wanted to be an astronaut. If I had become an astronaut immediately, as I wanted to, I would never have had the right training and experience and to demonstrate that I was capable of those leadership roles. And so in retrospect, I think it all happened for a reason, and it took more time as it should have. And I took advantage of it. That's something I think everybody has to remember, is sometimes your path is not always direct, but you need to be learning the lessons along the way for whatever that opportunity might be that's next in front of you.
Well, I think too is that it's like that path to those goals or dreams or passion, it's not exactly linear, or those delays are not exactly a no. It's just kind of a not yet. And then when that moment does happen, your tool belt is full of everything that you need. I do have a question about being chief astronaut. So my dear friend, astronaut Hoot Gibson and astronaut Ray Seddon, they just live up the road 30 minutes, as we say here in Tennessee. And he told me one time, I happened to ask him, I was like, all right, Hootie. He likes that I call him Hootie. He allows me to do that. I just have to say that to everybody. And I'm like, Hootie, tell me, is there anybody that you would not choose? Are there qualities you're looking for, or is there ever one quality that you go, nah, this is a no-go for me? Did you ever have those moments? And I'll tell you his answer here in a moment.
I do think that, selecting an astronaut is always something that you have to really think about, I've been on 3 selection boards, chaired one and co-chaired another one. And it's really important to pick the right characteristic. You want to pick somebody that you can fly with. And nowadays it has to be a long duration person, you know, somebody that you can get along with for a long period of time. You don't get to pick who your crew is going to be, but when you select an astronaut, you want it to be somebody that, if you happen to fly with them, they would be someone that you would want to hang out with, and for a long period of time. So
from his perspective, he said the person he would not choose was the perfectionist. He said that there was a candidate that was near perfect in the simulator, like near perfect, like every time, just nailing it, nailing the docking maneuver, until one day they weren't perfect and it fell apart. And this person couldn't pull it back together. And he thought, wow, I'm so sorry that I can't advance, but I need somebody who can stay cool, calm, and collected no matter the situation. So, you know, I always think too, there's a beautiful story that astronaut Leland Melvin tells of you and his time with you on the International Space Station. Apparently, you and the Russian crewmates, you guys were all sharing a meal, and you kind of like, as commander, were inviting everybody to take part. And it's very touching. I've heard Leland speak several times, and he mentions this almost every time, that it was that moment around that table, you know, so many hundred miles up above the Earth, that he felt a true belonging to, you know, the human family. And I just want to ask you, is that, I think I already know the answer, is that who you are? Was that what you are as a commander? Was that just trying to make sure and generate that energy that you need when you're working that long in space?
Well, I think it's really important to maintain crew cohesion all the time. And the best way to do that, I think, is around food. So, everybody come over and join in on a meal and contribute different things, and just laugh and tell stories and find out how alike everyone is, even though we might be from different countries or different origins and different life experiences. It's a unique way, I think, to remember that we're all the same.
Well, I love hearing that story. And you know what also struck me, again, it was a powerful video for anyone who hasn't seen this CBS note to self that astronaut Peggy did. But what struck me was a bit of your reticence to accept that you are indeed a role model, and kind of coming to terms with that and embodying it nevertheless. Is it hard for you to accept that moniker of role model?
You know, it's something I'm growing into. You know, it's hard to think of it just as, you know, I am a role model. I don't think of that per se, but then I remember somebody, you know, the Ellen Bakers and the Shannon Lucids, those first female astronauts, they were role models to me, even just by being there. And yes, I think I have been a role model as a leader and as an astronaut. And I really want young people to see themselves, young ladies, you know, minorities. I want everybody to see themselves in my spot and visualize that they too can be that.
And, you know, you're touching on something too, because of all the females who've, you know, gone before, and certainly you created a lot of firsts in your field, there seems to be this recurring thing that you weren't exactly thinking about your gender when you were doing all these things. All you were thinking about was being the best human or doing the best job you could. Is that true for you as well?
Absolutely. I think that's well stated. I feel like gender wasn't what I was worried about. I was always concerned about doing the absolute best that I could, and hopefully, you know, not that it's a competition, but be better than anybody else.
I don't think your name gets to be first in a lot of these things without being slightly competitive and super, super talented at what you're doing. I always love to ask this question. I know it sounds like your parents were huge supporters of your dream and your goal. Was there anybody else along your astronaut journey that played a specific role in you becoming who you are?
I feel very lucky in that I had role models, beyond my parents, but, even in high school, I had a science teacher who allowed me to make up my own science classes after I'd taken all the ones that were available. And then I got to college, and Dr. Greff was my mentor, and just she made me believe I could do lots of things. She was this like 5 foot nothing ball of energy that was always going, Energizer Bunny kind of thing. And after that, I got to Rice University, and my mentor, Kathleen Matthews, another just an amazing woman. I got to NASA, and I had two female mentors, Nitsa Cintron and Carolyn Huntoon, and both of them really encouraged me and supported me, and actually gave me opportunities I never would have asked for, like working in international relations. But I was encouraged to do these things and to try these things. And as I said, in retrospect, those are the things that made me successful. So you've got to take the opportunities, even if you don't feel that you can do them. You have to try, because you'll never know what you can do if you're afraid of failure. And when you test yourself, you can find out you're capable of so much more.
Well, I think that's a great lesson to all that are listening, and especially the students. Go out and find your science mentor, accept those opportunities along the way. Now, among 10 spacewalks, was there ever a daunting moment or a spiritual moment or some awakening when you're, outside the safety of the International Space Station, hurtling along and orbiting the Earth?
I think there's a special part of just being able to do a spacewalk, and the perspective that you get from being in space, not just during a spacewalk, but that perspective, seeing our planet below, is impressive. You see this blue glow, and it means life to us. And we see this very thin atmosphere. And as we're trying to construct an artificial environment beyond that atmosphere that protects us from radiation like our planet does, that provides oxygen like our planet does, removes carbon dioxide, and controls the temperature, and all these things that our planet does, it gives me the sense that, Earth is our spaceship, and we need to make sure that we take very good care of it, because it's taking care of us. But the thing that's most impressive is that at nighttime, you see all these thousands and thousands and thousands of stars. It's overwhelming. And then you realize that's just our galaxy. And there are billions and billions of galaxies. And we are not even a speck of sand in the beach of the cosmos. It is so impressive. This huge range of perspective that you feel.
And how did that change you? I mean, you've spent an incredible amount in space, but how did that overview effect change you or mold you?
Well, I just think it gives me an appreciation for this place that we come from, and an appreciation for exploration and what the future holds. With the more we will understand as we explore further away, will help us understand why we're here, where did we come from, and what is, kind of the meaning of our place in this cosmos. So I'm excited about it. That I feel that spiritual pull to continue exploration and keep searching for more and more answers.
Well, what now? What are your hopes for the first woman and the next humans that are going to put boot prints on the moon? And then what about those humans that will eventually venture on out to Mars? What now for you, and what are your hopes for the future?
Well, my biggest hope for the future is that we will do our exploration on the lunar surface in such a way that it's sustainable, that it becomes, something that is not just a visit and leave. I want it to be a sustainable thing that will draw commercial entities out further and further, because as we're seeing now, commercial industry is expanding into space, and if we continue and provide this infrastructure, that's provided, then people will come to it and use it as commercial ventures for, fuel depots, for missions to Mars or other things. And I mean, it sounds like science fiction, but you have to have that infrastructure to build out in order to take those next big steps and to allow the commercial industry to gain access. So I think it's a very optimistic, very positive future we have in space exploration, and I love the fact that the commercial entities are getting more and more involved and are going to help us expand the exploration of space.
Well, you certainly had your very formative Apollo moment, and the generation presently will soon have their Artemis moment. And I was talking with third graders this morning, and we were building our own lunar lander. It's a little less tall than the SpaceX design, but one of the things, it's like they are the age that they're going to have that moment when they see that happen. And do you have any words of wisdom for the Artemis generation? Maybe somebody who's 9 or 10 years old, just like yourself, when you maybe first saw, Neil and Buzz on the surface of the moon. What would you say to them?
Anything is possible, and you have to go after it.
All right. You heard astronaut Peggy Whitson say that. Any last words of wisdom? I mean, are you planning to write a book? I mean, what else is going on? Or you're going to go skiing? It's like, now that we can maybe finally move about, are there exciting things going on for you?
Actually, I'm consulting with Axiom Space. They are going to develop a commercial space station. It will initially be attached to the International Space Station, and I'm looking forward to that happening. Their first module will go up to the space station in 2024. So it's soon.
Any idea or any desire to go to space yet again?
Yes, definitely.
That's what every astronaut I talk to says. Awesome. Awesome. Well, we can only wish you the best. And again, congratulations on the National Space Society Space Pioneer Award. Personally, I am in awe. I've played that CBS video to students all over the place going, listen to this lady. She sold chickens. You got to do what you got to do to get there. So thank you for all that you have done and that you are continuing to do. It's so very obvious that you are one very fine crewmate in space, as well as here on Spaceship Earth. So congratulations again.
Thank you so much. It means very much to me that to have this honor.
And thanks to all of you for attending this session. ISDC 2021 has multiple opportunities for you to connect with the National Space Society. So if you aren't a member, please join and become part of our organization. We are attempting to push humanity outward into space. And as you can see, there are multiple ways for you to connect with the National Space Society, and we would love to have you become a part of our organization. Ad Astra, everyone.
Welcome back, everybody. We're back at Jet Propulsion Laboratory in Pasadena, California, and I'm here to give Robert Manning the 2021 Space Pioneer Award. This year's very special award reads, 2021 Space Pioneer Award for Science and Engineering, presented by the National Space Society to Robert Manning, Chief Engineer, NASA JPL, for discovery and solution for the Mars EDL problem. So Rob, congratulations. It's a real pleasure.
Rod,
This
Pyle,
is long overdue and well deserved.
Thank you very much. This is incredible. Look how beautiful this is. It's gorgeous.
Yeah.
And what an honor. The National Space Society, thank you very much. I'm deeply humbled and honored by this, and I'm not sure I deserve it, but I love it.
We're sure.
I really love it. This is really, really cool. This is amazing. It's the best ever.
It's such a pleasure to give it to you.
Look how beautiful it is.
As I said, I felt like it was long overdue. So let's talk a little bit about why you so richly deserve this award. You were integral to solving one of robotic spaceflight's biggest challenges of the 20th and 21st century.
Well, we were not the first. We had wonderful teachers. The engineers who developed the Viking Mars landers, and including the engineers who developed the human Apollo and Mercury entry systems, were our tutors. They told us the mechanics. They explained how the technology worked, what it needed to be able to do. We understood the equations. In fact, in those days, when they were developing their work, they did most of their work with a pencil and paper. Yeah. And we were on the cusp of using computers to help us solve these problems, but we had to figure out from first fundamental principles. But the most amazing thing is that it took us a while to realize that landing on Mars was really hard. Mars was very different than Earth. If you try to land, the great thing about landing on Earth is we have this thick soup of an atmosphere that we can land on. And landing on the moon, which is very different, has no atmosphere. It's an incredible contrast. Mars is smaller than Earth, only 1/3 Earth's gravity. And it's a thin atmosphere, but should be plenty to land. But it turns out Mars has too much atmosphere to land like we do on the moon, and not enough atmosphere to land like we do on Earth. Right. And that combination makes Mars really difficult.
So the atmosphere is just enough to be a pesky problem, but not enough to do you any favors.
Exactly. It's very pesky. I have to say, it's strange because it's really equivalent. If you had, imagine a mountain that was 130,000 feet tall, many times higher than Mount Everest, and your job was to enter Earth's atmosphere and try to land at the top of that mountain, you'd have a hard time. Why? Because you haven't had time to slow down yet. Well, what if you fire rockets backwards? Well, we didn't know how to fire rockets backwards while screaming through the atmosphere with thousands of degrees heating of that atmosphere as you're going hypersonically through the atmosphere. We didn't have that ability. You have to be able to slow down very much like we do on Earth with a heat shield. But by the time you're slow enough in the atmosphere to open a supersonic parachute, you're getting pretty close to the ground, and you're still screaming at 1,000 miles an hour when you open your parachute. 1,000 miles. Who on Earth, in their right mind, would open a parachute moving at 1,000 miles an hour on Earth? Well, the only place you can get away with that is 130,000 feet above the ground, or 190,000 feet, way up there. And so the technology we had for Earth really does not apply. We had to do something else. So having a supersonic parachute was the first key element. And the engineers realized that early on. And they tested parachutes early on at high altitude, way above the desert, above New Mexico, many years ago, in the early 1970s. And really taught us what the dynamics would look like for parachute inflation, how that really works, and what you need to do to build a parachute. At least that's what we thought. And as we went further through design, you realize even with the parachute open, because the air is so thin, you're still screaming toward the ground at over 200 miles an hour. You're going with a big parachute. You're falling toward the Earth faster with a parachute than a skydiver without a parachute falls on this planet. So a parachute really doesn't do the job, does it? You know, you need to somehow convert yourself, once you slow down, convert yourself from being an Earth lander to a lunar lander, and use rocket propulsion to slow you down as you get closer to the ground. So our vehicles have to be transformers. They go from interplanetary travelers to hypersonic decelerators to supersonic parachutists, and then subsonic parachutists, and eventually to the point where you have to separate from your parachute and use rockets to slow you down. And that formula was something that was discovered in the 1960s and 70s with the Viking missions to Mars. That's what we stole, and that's what we took those ideas and we ran with it. The thing was, back in the early 90s, we didn't have money. We didn't have the budget to pay for the rockets. It turns out the rocket technology that the Viking engineers had developed in the early 1970s was no longer around. It was gone. You couldn't get an engine where you can throttle up and down and control the force in order to control your vehicle as you landed. Think about it. How many applications are there on Earth for that sort of thing, or even the moon? We're not sending people to the moon anymore either. So things have changed. We had to come up with a new way. We couldn't use liquid rockets. We had to use something we could get off the shelf. We modified commercial rockets, solid rocket motors, and we used, and because solid rocket motors are terrible at controlling velocity, we aimed to just try to make sure we bring our vehicle to the stop some distance above the ground, and then we let gravity do its thing, and we dropped our lander from about between 10 and 20 meters above the ground. That's pretty high up. So at least you're coming to a stop above the ground. That's nice.
This is Pathfinder you're talking about,
This is
right?
Mars Pathfinder, and
Yeah.
this is what we had to come up with, this poor man's kludgy, very Rube Goldberg-esque lander, we had to come up with a lander that was that had to be surrounded by airbags on all sides. It had to be able to bounce on the surface. We first tried airbags that would decompress, so when you hit the ground, it would automatically vent like airbags on your car does.
Right.
You know, when if you get in a car accident, those bags inflate, but the bags allow it to compress as you fall into the airbag by shooting out the gas on the other side. We thought, well, we could try that. Well, we tried that, and it didn't work. The gas would come out too fast. It was hard to control, and what's more, we almost always bounced anyway. So we decided, oh heck, we got to come up with you just can't have airbags on one side. We had to completely surround it. That meant that we needed to come up with a lander that had to accommodate those airbags. So we ended up with a tetrahedral shaped lander. I mean, who would have thought make a lander the shape of a tetrahedron? I mean, especially electronics, they come in squares, right? Boxes.
Right.
You know, everything comes in square boxes. Somehow we had to shoehorn all these funny shaped electronic boxes into this shape, as well as a little rover, the first little rover, compress it down, squeeze its wheels down like if someone sat on it, and bolt it to one of the pedals of this tetrahedral shaped lander that had to also right itself, because if we roll on the surface, you didn't know which way you were going to land and which way you were going to roll to a stop, and which side. So it was like throwing a dice. So the dice had to be able to open itself up and right itself automatically. So all those things we had to kind of come up and invent as a poor man's approach to a poor person's approach to landing on Mars, and it worked to our incredible relief. On July 4th, 1997, we bounced Mars Pathfinder. We cut really high, much higher than we expected, and this thing plummeted from 7 stories up and bounced on the surface of Mars, boing, 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 and bounced probably a good half a mile along the surface of Mars.
And you weren't able to actually count how many times, right?
No, because my friend, my teammates and I, we said, well, how long would it take to bounce? So he says, well, we bounce this high, it'll roll to a stop. Don't worry, it'll roll to a stop. And I go like, okay. It didn't. So we recorded the data on board for 60 seconds. I mean, imagine you throw the ball and you throw it in the air and watch it bounce.
All right.
Can you imagine a ball that keeps bouncing after a
Who
minute?
would figure? Yeah.
No, it was still going. In fact, it was still going strong after a minute, and that's when it stopped recording. So I have no idea how many bounces it really did. And even though at the time I thought I had, I was wrong about that. Anyway, so we realized that this is one way to land on Mars, and these airbags seem to work quite well over very rough surfaces. We landed on Mars Pathfinder, a very rocky place. And in fact, one of the biggest things we discovered is that we might be able to land there and open up like a flower, but it's a really difficult thing driving a rover in some of that rocky area. And one thing we did learn about learning how to operate a rover remotely on another planet for the first time is that when you're this high off the ground, rocks that are this high are really scary, and there are lots of them. And so we really realized...
And you're looking at him from the viewpoint of the kid, right?
Yeah, it's like crawling on your stomach on the surface of Mars. And so it was fantastic. We learned how to do it, but we came away with the sense that, Mars is still a human scale place. In other words, it's not still a bad place for humans to wander around in their spacesuits. And I mean, and you have to prepare yourself to be, you need like a walking stick, because there's some pretty gnarly surfaces on the surface of Mars. And Mars has some really sharp rocks. That's something we didn't pay attention to early on. And later on, we applied the same landing approach for Spirit and Opportunity, and we landed those. And when we got to Mars in those missions, we looked at these pictures, and I was like, oh my gosh, that rock, that's an airbag eater. These are rocks that have been sharpened by millions of years, tens or hundreds of millions of years of the air is very thin on Mars. The dust does bounce on the surface. Little grains of sand march on the surface. They bounce on. They call it saltation, or bounce, and it bumps into these rocks, and it just ever so slightly chips it away and forms these sharp-edged surfaces called ventifacts, which occur here on Earth naturally, but they're very rare here. But they're ubiquitous on Mars, so it made me realize that we're going to have to make sure that we land on. If we ever use airbags again, we have to make darn sure that we're not landing on a terrain full of ventifacts, because the airbags are not happy there.
No. Now, wouldn't that be the opposite of what you would have expected before this mission?
Yeah. No, we didn't.
Didn't everybody expect windy-roaded, smooth surfaces for the most part?
I don't remember us talking too much about it. We never really talked about what millions of years of being exposed to that very thin atmosphere could do. To be honest with you, there was still debate whether sand dunes ever moved at all on Mars. We did not have many years of orbital high resolution images that would show dunes progressing over time like they do on this planet. So there was a thought that there wasn't just enough, this wasn't a force to be reckoned with, but it is. And dunes do move on Mars. Sand does, in fact, sand and dust on Mars still plays a huge role in changing the landscape of Mars, even today, after all these years of being dry, since the end of the wet period about 3.5 billion years ago.
Right. We've kind of gone through this march towards EDL pretty quickly, but you did a lot of testing.
Oh, we did a lot.
Especially on Pathfinder, as I recall, you did some innovative, kind of non-traditional kind of testing. At least non-traditional, what we think of when we think of NASA.
So one of the things our ability to do computer simulations of all of this stuff, which has improved over the years since then. But in the early 90s, our skills at modeling were pretty rudimentary. And for example, we tried simulating what an airbag on a sharp rock would do, how that would work, but we couldn't get the software to tell us much that was useful. Instead, we just had to go back to the good old-fashioned trial and error. So trial and error was part of it, particularly for airbag testing, but airbag retraction, rocket firing, parachute inflation, and going back to relearning how to test heat shields under Mars conditions. It had been many years, right? We've been 20 years since the last landing, and many of those tests occurred many years before that, in the early 70s, so or even late 60s. So we had to go reconstitute the test program, test capabilities that had really gone into mothball or retired altogether, and pull out many of these wonderfully talented people who were in their 20s in the early 1960s,
right,
who had helped invent some of these ideas. And so they came and gave us advice on how to test, and we took what they did and moved the bar even further.
With a lower budget.
With a much lower budget, yes. We were only 1/10 the cost of the Viking. Of course, Vikings had 2 orbiters and 2 landers, to be fair, but it was still a lot cheaper than in the same scale. And a lot of it because we had the people who still remember how to do it give us advice, and we're very good at test and fail, test and fail, test and fail, test until it worked. And we were very because we had those test abilities, test skills, and test setups. We bought a lot of hardware and tried things out, and until we got. In fact, the original design for Mars Pathfinder, the sensing of the ground was not going to be electronics at all with a radar. It was going to be a plumb bob that was going to be lowered on a 20-meter or that was actually 60-meter bridle. That would just when it hit the ground first, it would send a signal up to fire the rockets.
We're here. Yeah.
But over time, we realized, because when we did more, this is where we did use computers, we started realizing the dynamics of parachute, rockets, lander suspended below that on ropes, 20-meter ropes, by the way, with the airbags surrounded, and then another rope that went down to sense the ground. That was swinging so wildly that these things, the lander would land sometimes in our simulations before the touchdown sensor, and so which not be good. So
Okay.
so we would not have the airbags inflated. That would not be good. So we realized, but all this time we were testing our rockets and other things on the desert with a very low-cost radar, just a few $1,000 radar that we had purchased, several of them for our testing because we were dropping them out of the sky and they were crashing and breaking. He goes, these radars work pretty good. Maybe we should send one to Mars. So we took one of them and took it apart, make sure all the parts were of decent pedigree, and worked with the company who made it. And sure enough, the radar worked fine, and it had some idiosyncrasies that we had to work around. We pulled it together and tested it and tested the daylights out of it, and sure enough, it worked. That's what we flew to Mars, a little few $1,000 radar that you could put on an aircraft. It's really an aircraft radar.
Yeah.
It was great, and it worked. So we used that to the software on board the lander used that to time when the airbags and the rockets would need to fire. So we learned all those things, and of course all these things that we learned, we applied directly when it came time years later to come up with a new rover that was now of substantial size. It's the size of a golf cart now, which is actually more reasonable thing to drive, because Mars, we did realize that Mars is, this is a rough place. There are rocks and boulders and all sorts of things all around us, everywhere we looked. We needed something, and a little rover like this couldn't go that far. And one thing we really, at that time, no one had ever put a vehicle on Mars other than Sojourner that could go very far. Sojourner could only go as far away as your backyard. They could explore your backyard, literally. It's just much less than the size of a football field. Why? Because we had a little radio that was in contact. It had to be line of sight communications, and we had to be able to see what it was doing so we could control it.
Right.
Because its view of the world was so tiny and so limited by all these rocks around it. So this we really did learn that we needed a bigger rover. Now the question is how we're going to get a rover there, and that was. We had tried ideas of landing a bigger rover on a lander, like with legs, very much like you see that the Chinese have used. Mm-hmm. But because we had very little understanding of where to land, and we didn't have the technology for onboard hazard detection or even localization to figure out where you were, as our current rovers do, we need to make sure that we had to be able to make a design vehicle that a rover can escape and drive off. In very nasty terrain on slopes and rocks. So we found that the lander just was not working out, and so we came to this idea that maybe we should take Mars Pathfinder, particularly after the Mars Polar Lander failure. The mission, as you know, that lander vanished in 1999. Right. We've not found any signs of that lander on Mars. There's no debris. Nothing. It's been gobbled up by Mars, or vanished, or broken apart. Yeah. We don't know. And so, but we really felt back in early 2000, after that failure in 1999, that we needed to do something else. So we said, well, why don't we just? My friends and I came up with the idea. Why don't we just take our Mars Pathfinder, ditch Sojourner, and convert the inner part of Pathfinder into a rover. Basically make that into a larger version of Sojourner that had larger wheels, had better ground clearance, and can carry a science payload that was originally intended to be on a rover in the first place, that was being put on landers, or really was meant to be on a rover. So we did that, and Sojourner, the Pathfinder, basically was the parent for Spirit and Opportunity, which is convenient because the next launch opportunity that we could aim for was 2003. 2005 was a terrible time to go to Mars because of dust storm season. So we realized that we could take Mars Pathfinder design, modify it, and in 3 years build a rover. Well, that's about the time we made that story. We got a phone call from Dan Golden, NASA administrator, and he said, "Hey, why are you guys only flying one rover? Shouldn't you be doing two?" And we said, "Sure. Why didn't you just propose that?" Well, wouldn't that make more sense? And we were like, "Yeah."
You bet.
So he said, "Well, can you do it?" I says, "Well," we said, "I don't know. Should we do it? Guys, what do you guys think?" "Yeah, we think we can do it. We have no reason not to. We have enough chambers. Yeah, we think we do." "Okay, yes, we can do it." We didn't know we could do it or not. But it turns out we were very glad we did, because not just did we send two more rovers to Mars, we could not have launched one by itself, because the two rovers complemented each other in their testing, allowed us to double up the testing and get twice the testing done in half the time. It's really great, cut the time in half. And so it was very successful. We to our shock and dismay, we managed to get them off the ground just in the nick of time before the very narrow 3-week launch window closed, and off they were, headed to Mars, and we landed them in early January of 2004, and that was our success. We learned a lot about driving on Mars, exploring Mars. For the first time, we were able to not just stand and look out the window, look around. Look at that hill over there. I wonder what that is. I don't know. It's too far away. Okay, well, look over there. Oh, that's a nice like rock. Wouldn't it be nice to get close to that? Yeah, it would. Yeah. So that was the world of landers. The world of a rover was, well, let's go over and check it out.
Yeah.
And we did. We would go over and check it out. I remember our first drive on Spirit, we took a drive north because there's a big crater, Bonneville crater, just a few football fields away. We drove up to it and climbed up to the rim of the crater, hoping to look inside to see rock outcroppings we could explore. Not a rock outcropping to be seen. And we're like, oh, shoot, whole disaster, because we expected this crater to be full of signs of water, because it was clearly a lake at one time, but all we found was lava rock. And it's like, that doesn't make sense. Oh, obviously it was a lake, but it got covered.
That was Spirit?
That was Spirit.
Yeah,
Spirit rover, and in Gusev Crater. And we looked, and so we said, well, it's just lava rock as far as we can see. Apparently the lava covered the lake, but we didn't know that till we got there. And so, shoot, well, how about this? There's some hills over there. Let's drive over there. Well, they're about a mile or two away. That's a long ways to go. We designed these rovers for 600 meters. I go, Total.
Wow.
That was our requirement.
Kind of outdid yourself, didn't you?
Well, we designed them. When I say design them, we designed them. We ensured that they had a high probability of going 600 meters.
At least, yeah.
Or more.
That's remarkable.
So it was we designed for at least 600 meters. We don't know. We didn't know. We were concerned because our testing of those motors, running especially brushed motors, operating in those conditions, revealed that these motors aren't going to last that long. And we also knew their solar arrays weren't going to last that much longer because of the dust accumulation they were claiming every day. A little more dust on those things. So our expectation was that they wouldn't last that long for those reasons alone. And so we plowed ahead, crossing our fingers so we'd get to the mountain before the rovers died and before winter. And we did. We made it there before winter. And guess what? Mars cleaned up the dust, and so the dust was wind conditions occasionally show up. Wind conditions occasionally show up that completely scour the tops of the solar panels, leaving them as clean as the day you landed. I mean, who would have thought that? We never dreamed that would happen. Now, it doesn't happen very often. It only happens a certain time of the year. It doesn't happen every place, but it could happen, and it was something we couldn't count on, but there you go. This happened several times over the course of both Spirit and Opportunity rover. So I have to admit, these rovers were successful far beyond our wildest imaginations. It was quite lucky.
Well, and what a story, and it got so many people engaged worldwide. Yes. And they picked up an anthropomorphic personality, and they became an entity unlike, I guess, anything you could really predict. I mean, Pathfinder and Sojourner were cute.
They were.
The Murs were handsome,
They were handsome.
Or they were still cute, but they were like a Mastiff instead of a Poodle or something.
It is. There was some substance to them. They had that kind of like, housefly-like wings.
Yeah.
But they had this, which when I first saw that, we were first designing different ideas for so we needed larger solar panels, and I talked to my friend Dara Sabai and a few others in the team. They said, hey, we need larger solar. Says, well, can we? So a few engineers brainstormed various ideas, and a design popped out, and I go, and you look at it and you go like, yeah, that's it. That's it. Certain designs, you just look and you go, yeah, that'll work. You don't even have to think in deep, like, well, I'm not sure that's going to work. No, that's the way to do it. You've got it. And so it really saved the day. And but in the process, all this time I'm wondering, we're building these things and we're struggling to land these things because the timeline is very tight with that parachute. Our rover, this vehicle is turning out to be heavier than Pathfinder, quite a bit heavier, and even it's the same volume, same airbag design, and everything else. How are they? If I'm having trouble landing these things on Mars, right, how the heck will people ever land on Mars? So I was fortunate in around 2004, 2005 to help lead a team of experts, including Apollo astronauts. Very cool.
Yeah.
Other shuttle astronauts, the rest of the entry, descent, landing community, as well, both the planetary as well as the human community, all get together. The Johnson Space Center people. It was wonderful. We got together and we had this series of workshops to basically tell each other our stories. And it was in that effort we realized that we had a real problem on Mars. We had really not thought through the problem of landing on Mars, and particularly the hard part was going from about Mach 4 times the speed of sound, which is a little bit slower than Earth's speed of sound, but not much, to down to zero before hitting the ground. The whole trick to landing on Mars is or landing anywhere is basically to come to a stop before you hit it.
Right.
Right. That's sort of the guiding principle of EDL. Don't hit it too fast. And so you're screaming toward the ground. If you got this very big vehicle, how do you slow it down? Well, if you're going supersonically, supersonic parachute would be the size of the parachute with the size of the Rose Bowl. We figured we needed a parachute that was really this massive piece of fabric. How long would that get that fabric out there? How do you get it inflated?
Yeah.
It was very difficult. And we realized we had to come up with new options, new kinds of drag devices, new inflatables to slow down further up, even more.
Mm-hmm.
And with the whole trick, once you get below the speed of sound on Mars, then you can fire rockets like you do on the moon. But above that, the thought was you couldn't. But we had one idea. Well, what if you were to fire rockets backwards going supersonic? Well, we could do that, but no one's ever done that before. Mm. No one's ever fired rockets directly in the direction you're traveling as the air is blowing back on you, producing a little bubble of terribly chaotic hot gases that could be whacking on the back of your vehicle, causing you to tumble and roll, and who knows what would happen. And so we said, well, we'd love to figure that out. Wouldn't it be great if somebody actually had enough money to do that? And so we left it at that. And we said, well, this has been an unsolved problem. And we realized, so I wrote a paper with my friend Bobby Braun, the other winner of this prestigious award. And Bobby and I basically wrote a story explaining this. I simulated all these different ways of landing on Mars, the different techniques and ways to slow down to get past this supersonic deceleration problem that we have with all these large vehicles. And the cool thing is that we realized that this was a really hard thing, and people really didn't know how hard it was until we pointed it out in a big way in 2006, 2005, 2006, when we wrote our paper. So the most amazing thing is that we said, well, in 2005, we said, listen, if we want to send people to Mars, say by the 2030s or 2040s, we're going to have to learn these things. We're going to have to solve these problems. We'll need to figure out how to do relatively large, full-scale testing on Earth, way high up, to check these technologies out and try them out. So we did. We launched on a bunch of parallel efforts to try to come up with new ways to land. One is a hypersonic decelerator that my friends at Langley worked on. My friends and I worked on these new large supersonic parachutes, new large supersonic inflatable devices, Ballots, a device that pulls out that helps you slow down at, say, at Mach 4, Mach 5 before you can open a parachute, to help aid on all this deceleration problem. Meanwhile, my friends over at SpaceX have realized that they need to return their boosters back. They want to land their boosters, but these rocket boosters are going way up high and they're going way supersonic, so they have to somehow turn their rocket boosters around and then slow them down to come back and land back on a barge somewhere. And that so we realized that people like Bobby and I realized, hey, they're doing the tests that we wanted to do in 2005. They have a reason to make this work. Hey, can we collaborate with you guys and learn about how to land, learn how the dynamics work? When you fire a rocket back into the atmosphere, what happens? What does the air do? How hot does it get? How does it affect your vehicle? Do you get bumped and buffeted around? And the answer was, no, you don't. It's not that bad. And so, oh, this is great. So essentially, they helped us solve the Mars lander for human scale landing. Now, we still haven't done it at Mars. Someday we will, but now we're building a new after. Of course, with Curiosity, we realized that we could still use the Viking technology if you make the aeroshell bigger. Right. But now you had a problem, is that how do you touch it down? We could go back to the Viking throttle engines, and we did. It took us about 6 years to reinvent those engines, but we needed some way because we realized that landing on top of a big lander, a metric ton or a vehicle is huge, and it's hard to get off a lander, because even when you may be only at 2-3 meters above, 1 to 3 meters above the ground, you still haven't landed yet. Right. You need to drive off, and how do you get the thing off? It's so big, it's so top heavy too. So we said, so my friends and I, about the same time that we invented Spirit and Opportunity, we realized that if we can turn the rockets upside down, we can put the rockets on the roof and make a jetpack, make it like a helicopter, and fly it and lower this thing down on ropes, just like helicopter pilots do up in the sky, where they will lower payloads down, and they can do it with incredible precision. And so we got some more astronauts and more helicopter pilots to vouch for our concept of lowering the vehicle down with a descent stage using the sky crane maneuver that lowered the rover down to the surface. And that was the idea we came up with, again, a long time ago now. It's been over 22 years since we came up with it, 21 years.
I didn't realize it was that long ago.
Yeah,
so
it was January 2000. Even before we came up with Spirit and Opportunity as an idea, we were playing around with that idea. We discarded it for a while, thinking it was too hard, but while we were working on Spirit and Opportunity, we realized we can control things on the end of a rope. Turns out it's not that hard. In fact, if you take a pendulum or anything on a piece of weight on the end of a string, try swinging it back and forth like a pendulum, it seems like it's be hard to control. No, it's not. Just move your hand over and it comes to a dead stop. You can do it yourself. It's a great, simple experiment. We discovered that while we were trying to control the speed of our back shell when we were landing with our airbags, Spirit and Opportunity. And then we realized, hey, those things work. So my friends and I came along. We said, let's try this idea out. And we made a big team in about 2003. We started a big team to kind of work this through. 2002 and 2003, we started working this out, and the idea finally got accepted as the way to land on Mars in 2006, years later, when we took it to the new NASA administrator at the time, and it was a wonderful success. So, and that, as you've seen, it's worked twice.
Yeah.
It was a great way to land a rover, both Curiosity and now Perseverance, and now we have video to prove it really happened. Right. We can actually see the descent stage flying up away, and that most amazing video of really just kind of realization of our mental. You hold these things in your head, and you visualize it all in your brain, but sometimes you have to come to a stop.
So just to kind of wrap it up, do you see using Sky Crane again, or will you be graduating to something else next time?
I think Sky Crane has its purposes and useful uses. I mean, if you have a vehicle that's smart enough to be able to find a perfectly safe place to land, right, you can land with legs. The great thing about Sky Crane, it is the slowest landing you'll find anywhere. I mean, even the rocket landers, they can't go infinitely slow. Why? Because the rocket's so close to the ground, they build holes. Unless you land on a pavement, right, like a landing pad, like SpaceX does. It's really hard to land on unprepared surfaces. So the Sky Crane architecture separates that, decouples the landing from the control in a way that's very convenient for vehicles that have landing gear already, such as the wheels of Curiosity rover or Perseverance rover. So right. So I think Sky Crane will be a thing going forward. It won't be the thing. So I think there's going to be many ways of doing it, and there is no one right way to land on Mars. There is no the best. In fact, even our Sky Crane architecture is the least unsatisfactory engineering solution right. for landing a big rover. But it wins on that score all by itself.
Yeah, that's an incredible story. Thank you so much.
You're welcome.
And a real pleasure to be able to bestow this.
And thank you and the National Space Society and for this wonderfully prestigious and humbling award with so many amazing, illustrious engineers and scientists in the past. I feel I am not worthy to be part of this great group, but it's a great honor, and I really thank you very much for this award.
More than worthy. So thanks again.
You're welcome.
Welcome back, everybody, to this continuing International Space Development Conference. I'm very pleased to bring you Tariq Malik, who is the editor-in-chief at space.com, among his many other stellar credits. And I'm Rod Pyle, the editor-in-chief of Astra magazine. Now, where I have to put together a quarterly magazine for the National Space Society, which I enjoy doing very much, Tariq has the dubious honor of putting together space news every hour of every day. And we have some interesting space news today coming down from Ganymede. Why don't you talk about that a little bit?
Well, it's just an amazing time for us to be exploring the solar system. NASA's Juno spacecraft has made the closest flyby of Ganymede, the largest moon, not just around Jupiter, but in our own solar system. And it's bigger than our own moon, if you can believe that. And so, and it's just beamed back these amazing images of this giant icy landscape that is Ganymede, which I know that I kind of really got close to home with from Farmer in the Sky, that iconic Robert Heinlein book. But it's just an amazing kind of new view, our closest views yet to know what these icy satellites really look like, and hopefully maybe even to set some of the groundwork for future missions to Jupiter.
Yeah, and I remember reading there was some hope that they might be able to get a little more data on the possibility of subsurface ocean there as well, which would make it, if they do that, if they're able to do that, that would be the third confirmed oceanic moon. Is that correct?
Yeah, well, you've got around Jupiter just a lot of great targets. You've got Callisto, you've got Europa, moons that have been known to have water below the surface. Ganymede has a really hard rocky crust, but the past observations do suggest that it also is just an icy kind of terrain, making it kind of a nice target for a mission, maybe a future mission like the Jupiter Icy Moons Explorer JUICE that's coming up, and this kind of flyby, getting these closest looks, in over 20 years, just over 20 years or so. Really kind of help set that stage, to probe it not just with imagery, with the other instruments on Juno to kind of look deep at this satellite, as it has some of the other moons of Jupiter itself over the last few years.
So moving a little closer to Earth and what's going on here with human spaceflight, we've been getting a lot of news lately about private spaceflight, private space stations. We've got Inspiration 4 coming up, which is a private buyout of a SpaceX Dragon 2 capsule. We've got the Axiom node going up to the space station, module, not node, and a bunch of other stuff in planning. At the same time, we have the Russians saying, hey, we want our main module back from the ISS. We're going to take our toys and go somewhere else. What do you see in the next few years of human movement off Earth?
Well, I think, Rod, you and your attendees for ISDC are no strangers to the promise of space settlement. It seems like every year for the last maybe 2 decades, we keep thinking that this is the year that we're going to get closer to settlement in space, to space tourism, to a much more open industry and access for space. And I think that I can finally say, without hyperbole, that this actually may be the year that happens. Not only do we have a lot of an expansion of access to space, we have new vehicles like SpaceX's Crew Dragon, which is now flown 3 times while we're speaking now. Astronaut to the station. It will fly the first private mission to the space station into orbit, not the station, later this year with Inspiration 4, financed by a non-professional astronaut, Jared Isaacman, with 3 other civilians along for the ride. And then you have Jeff Bezos on the other side with Blue Origin auctioning off a trip to space with himself and his brother. But all of these things are happening, it seems, kind of chock-a-block. We talked about Blue Origin, but Virgin Galactic also has been flying people to suborbital space. Sir Richard Branson, had hoped to be first on that, and it seems like he might be vying with Jeff Bezos for that honor. And when you have all of these things all happening at the same time, you can see that there is a reality now. Like it's actually happening, regardless of the policy that we see in Washington or even with the International Space Station partners. Right? Russia is kind of in a back and forth with NASA and the United States on access to the space station and their own plans for their new module Nayuka, as well as maybe another space station. Actually, there are discussions now to independently fly space tourists. They're going to fly a director and an actress to the space station to film a movie there ahead of another planned one that NASA has been working with on the back end. So you have all of these different kind of outreach efforts that are not just purely science exploration by professionals. And it does seem to be leading up to a watershed moment of this true expansion for access to space. It's not just all of these kind of high-end, Air Force pilots or test pilots. It is a good mix of everyone. These are people on Inspiration 4 won contests to be able to go to space. And one of the things we were talking about earlier is Axiom Space, and they actually have 3 different missions to go to fly people to the International Space Station, in addition to their own private module that they're building. And it does seem to point to an environment in which not only is there a willingness to embrace this new industry, this new expansion, but there is the actual capability now. These companies are building the hardware. They have space planes. They have successfully and already flown vehicles that have gone to space and back, that have carried to space and back. And now it's just kind of a matter of time to see how, just as in the early days of, let's say, aviation, where maybe flying on an airplane across the country was a really novel, super expensive endeavor. When will we get to where we are now with that industry, where you can kind of get online and book yourself a Priceline trip for a fairly affordable price? So that, I think we're still pretty far away from that. I don't see the a trip to a space station, a private space station, being below a few $1 million, if not more than that, for the foreseeable decade, perhaps. But I see a willingness of people to gather their resources together to fly someone that is not maybe a singular billionaire to go to space, or companies to finance their own trips or their own contests. There are reality shows that are actually going to fly people to space that do seem like they're not pipe dreams anymore. The Discovery Channel is doing one, which is not a small name. So it does suggest that that's actually going to happen. And I do feel like what we're going to see just this summer alone is a massive sea change in that access to space. What is an astronaut? What is a destination to go to? China has their own outpost in space. Is it going to be purely for their space program? Will they open it up to civilians? Will they have international partners like Pakistan and others that they've already signed deals with? I guess we're gonna wait and see. But we could be seeing in the next 5 to 10 years 2 to 3 different stations in orbit for people to go live on, demonstrate new technologies, new settlement concepts, and that where we haven't talked about the moon yet, where
Right.
companies like SpaceX already have sold trips around the moon, while NASA has embraced them as also a method of transporting its own astronauts to the moon. So there's kind of a whole other race or contest to get back there and build up a base between NASA with Russia and China. They've got plans for a moon base, and we might just see, if all of this private stuff with the station works out, another attempt for a private moon base, which we had seen with Shackleton Energy and whatnot in the past.
It's interesting when you talk about space tourism, it seems, and I'm not knocking it by any means, so I hope people won't take this wrong, but it seems like we have right now 1 foot in 2021 and 1 foot in 1961, in that, yes, we're flying reusable craft, but they're suborbital. So it's a little bit better than a Redstone lob, but it's kind of the same general idea, right? You go up, you skim the edge of space, you say, yay, I got my wings, I'm a citizen astronaut. And then you come back and either land under parachutes or on a runway, which is great. And it's affordable for some of us, probably not for most magazine editors, but for some of us, we can, take out a second mortgage and drop $200,000 or whatever it's going to cost. And you kind of touched on this, but maybe a little more detail. If you look in your crystal ball, since you're on the hot end of the news fire hose every day, I just kind of let the tap dribble over here. When do we see, $50 million to space station are one thing, right? There have been proposals, some of which appear more serious than others, about truly tourist-oriented orbital stations and about tourist flights to the moon and the lunar surface. Are we talking 2030s, you think?
I normally I would really hedge my bets and say I'll believe it when I see it. And I have to say, and I think this, Rod, I did have to eat my hat when I said that about SpaceX landing rockets back on the ground, and here we are, something like 87 landings later.
Where you use ketchup on your hat? I think I can say, if I have to look into a crystal ball, where I personally would expect to see our capabilities as a species, with either a private space station. I would expect by the end of that decade, by 2030, at least a provisional private outpost in space. And let me tell you why. Because what we saw during the Bridenstine years at NASA was a big expansion on commercial partnerships in terms of supplying all of the individual elements for the Lunar Gateway, as an example, that space station around the moon, where you have Maxar providing a propulsion bus and Northrop Grumman providing a habitat. Those are all companies that are going to design their systems with a set of specifications, but not super, close micromanagement from NASA
to develop this. And once they develop that, this is what we've seen with SpaceX, with Blue Origin, with Virgin Galactic. Once they develop that technology, they can use it now for whatever they want. Northrop Grumman has been talking in the past about, United Launch Alliance has been talking in the past with private companies to fly private modules. I think that was with Bigelow Aerospace, and sadly they're not around anymore. But the feasibility now seems much more accessible on an industry standpoint to set those destinations up. The trust level on the space exploration side has changed. They now embrace that commercial approach. Now there's always the checks and the balances and making sure that things are going okay. But seeing a flight like Blue Origin actually begin crewed flights in 2021, seeing Virgin Galactic really kind of pushing their vehicle to the limits before they begin passenger flights in the next year, and seeing a free flight mission, which we had been expecting from SpaceX for many, many years. I think they initially had a free flying Dragon concept before they even began flying cargo for NASA. Seeing that actually happen in September, and it looks like it is actually going to happen, is really going to kind of crystallize that approach now to future missions, future partnerships, and then future independent missions. The fact that Axiom has 3 missions to the space station means they have a customers that are willing to finance those. And with many new companies developing more reusable vehicles, we could see that cost then lower to the point where it does become accessible to take a once-in-a-lifetime vacation for you or for I over time, and then for our great grandkids to hop on a flight and just take in an orbital sunset for an afternoon or for a weekend.
Yeah, and so we're talking there about space tourism, and I do think it's sensational that Bezos is stepping up to take the first one. That shows a bit of moxie. But we in another segment in this same conference, we interviewed Jeffrey Manber from NanoRacks, talking about the new Outpost program, which will repurpose spent stages in orbit. And it's interesting because if you read some of the media reports, I'm not sure all the reporters were clear on the fact that, at least they didn't make clear in the articles I saw, I think you probably did, that we're not going up and repurposing tumbling second stages that are there now. They have to be built for that purpose and then flown. But at the same time, their initial mission, as you know, is to go up and test cutting various assemblies with a welding torch in space, cutting torch. And that brings up some interesting possibilities, not just for repurposing spent stages a la a smaller version of Skylab, possibly, like what the wet workshop would have been, but perhaps assembling other things out of those. And he didn't give us a lot of details, but tell us what you know.
Well, what I can say is that has been kind of a dream of science fiction. I remember reading some Larry Niven books that specifically where they would take the old external tanks and turn them into space stations. But I know we were talking a lot about space tourism, but that really is kind of the tip of the iceberg, right? You'll have a lot of these kind of early people with the means to pay for it, make these trips, and somebody will then say, you know what, I bet if I did this or tried that, I could do something a little bit different. And that's what we're seeing with companies like NanoRacks and others that are looking to kind of really build something in space with components that we already have, or things that are affordable to launch into orbit. So there's a lot of technology that has to be proven out for something like that, especially when it comes to repurposing stages, because once you cut into them, how do you make them airtight again?
Right.
How do you outfit them so that it's comfortable for you and I to just take off a spacesuit and be there in a shirt sleeve environment? We saw a lot of that with Skylab. That was a big space station, right? So we know that we can do it. It's just a matter of can we do it in space in a safe and an affordable manner? And what we've seen with companies like SpaceX, where they've really refined a method of flying things over and over again. I think that we're going to see that kind of an approach be a bit more embraced by other different companies to then set that infrastructure up, so that other companies might want to come in and say, yeah, we'll be the Hilton of your station right now, and someone else might say we'll be like the Marriott, right? And
Yeah.
and then they might have some dueling trips. That will take some time. I think something simple like one core module by the end of the decade does feel very possible. There are many companies that are building them on a commercial approach for actual agencies, for the Lunar Gateway, an international program for the station. And Axiom does seem like they're really poised to kind of be the first with their module that's supposed to fly in the 2024 timeframe. So maybe around the time we might see SpaceX finishing their first lunar lander for NASA, we could see that first commercial module on the station. That is a substantial size, because we have the Bigelow beam inflatable module there as a prototype, but Axiom, of course, looking for something much bigger than that.
Well, there's so much more to cover, and we're almost out of time, but I have to say, I don't know about you, but unless I make a substantial career shift, I'll probably be looking at the Motel 6 of space, if not something more akin to a Japanese capsule motel. But I'd take that in a heartbeat.
I would take that. I've had many vacations where that was our stop, and we had a great time looking at the Grand Canyon or whatever it might have been, and we just had that place to stay. So you can imagine even a budget hotel in space that offers spacewalks at a discount. People are going to gravitate to something like that.
You bet.
Russia just right now has, as we're speaking, released a new website where people can kind of tailor a flight experience to the space station with one of their Roscosmos's subdivision companies. That's the kind of thing that I think we're going to see a lot more of. And then as that progresses to these private modules going up, tailoring that to what do you want to bring? Do you want to do experiments? Do you want a special camera that'll fly around and record everything, so you don't got to worry about taking your own selfies? We're going to see a lot of that, I think, come up, and we're going to see it tested on these earlier missions with these private companies.
Well, I seem to recall a couple of years ago, I don't know that your company paid for it, but I think you and I and Mike Wall were all kind of looking at a zero-G flight that you ended
that's
up.
right. I went on that flight, actually.
Yes, I know. I was a little toasted about that, because I thought, oh man, I mean, of course you should go, but a guy can wish. But anything coming up in the near future similar? We had
the great honor to shadow the University of California, San Diego's microgravity team, and you'll remember they were testing.
That I did the story on before you went. Yes,
that's right. You visited them, and then I got to go meet them during the flight campaign that NASA used to have for students. And I tell you, that was a really great thing. But that company, Zero Gravity, still, really that shows a lot of that crossover, right? Here is a technology that NASA, that Roscosmos designed to train professional astronauts. And now here is a company doing the same thing, but flying students and flying tourists at $5,000 a pop, and doing that on a regular basis. So it is a kind of a niche market, but it is a market now, and I'm fairly certain that they don't really hurt for customers. And $5,000 is not that much for a vacation, right? For some people who are saving for an annual trip or a once in a lifetime trip, it's a goal that can be attainable for some. And so I feel like we're going to see that kind of a model really be adopted on a larger scale for these orbital flights, for these trips to maybe to Ganymede, where you have a base that is tapped into that icy soil or that icy ground and is looking for what is the Ganymede equivalent of geothermal power, so that farmer in the sky book is a reality that people can take a trip out there in the future.
Well, thanks very much for joining us, and I hope we can do this again soon.
Yes, hopefully in space one time, Rob.
Well, yeah, that'll be the day. Keep up the good work, and we'll see you again.
Well, you too, and thanks a lot to you, to the National Space Society, and to the folks at ISDC that are really kind of making it all happen.
Well, this debate opportunity has taken that bold step of bringing it into the domain of young adults. If what we've done is created that energy and that interest. When you see these students speaking about it and using the terms that we use as if it was always their term, I don't think there's anything more rewarding, quite honestly.
Universalization is the act of all the nations on Earth, all the people coming together to tackle problems that affect us all.
Universalization, in my point of view, will change the world to a better place and a whole new league of problem solving together.
Figuring out a plan for universalization space is something that's really important and is really impacting us right now.
We want every individual involved in every matter because we're humans and this is our world. We need to rule it together.
We want all countries to be able to have that international collaboration that's going to bring us all together for a common cause.
Find a way to agree on new laws in space that are helpful and that everyone can cooperate and agree on.
I think it starts now and we begin that conversation, and as we plan, we are making way for generations to come to go to space in peace and borderless to boot.
You don't see that borders, you don't see that differences. Just like we have seen in the debate now, the students from different countries are actually part of a team.
The opportunity to put it in the hands of our next generation of leaders is what we need to do, because they're the ones who are going to help us really resolve, because it's their world. They need to own this.
Do you guys all want to live in space?
Yeah, sure.
It's my dream, actually.
It's like a magic. So we can discover all the things in space.
Space is a mystery. It's filled with adventures, and I just want to touch the stars.
Well, Gwynne, thanks so much for making time for us today.
Thank you, Rod. I really appreciate it.
I'm really pleased to be here to present you with the National Space Society's Wernher von Braun Memorial Award, which is presented every other year to outstanding individuals and entities. And this is SpaceX's second such award. The first we presented to Elon in 2014, which I've noted in your lobby when I came there to interview you a couple of years ago, and I was thrilled about that. It was a really wonderful surprise. So just kind of in a nutshell, SpaceX has been so instrumental in revolutionizing how we access space and has really changed the way the world looks at the future of spaceflight, which is not an easy thing to do. I don't need to tell you. And you have had a profound role in every step of that. And it really seems like we see something new, exciting, and transformative occurring every couple of weeks, which, I mean, that didn't even happen in the Apollo program. So this is just, I mean, it's thrilling. I can't even find the words. A few years ago, when you flew the Falcon Heavy for the first time, I felt like after all the talking that journalists like myself and others have been saying about the new space age, that at that moment it had finally arrived, and it was just incredibly inspiring to everyone around the world. And as a space writer, I'm continually amazed at how both the company, as you and a leader, have completely reinvented the conversation around spaceflight. Could you talk a little bit about what we should be expecting in the near term for both SpaceX and Starship in particular?
Yeah, absolutely. And by the way, I want to thank you profoundly for the award. It's obviously, I always accept awards on behalf of the men and women of SpaceX because, you know, frankly, compared to the work that they do, I feel like my effort is so tiny. And so thank you for the acknowledgement. I accept this award on behalf of I'm pretty sure nearly 10,000 men and women at SpaceX we have right now. I'm thrilled that we were able to achieve what we were last year during the crazy, you know, really kind of a crazy global time frame, and really pleased with the team. They did extraordinary work. But as far as what are we looking to in the future, we've got a number of major developments that are ongoing. I think the one that people are the most excited about from a visionary space perspective, of course, is the Starship program. From a practical perspective, I think many people are very excited about the Starlink program, and we will have just
talk very briefly about that. We will have full continuous global coverage based on the last launch that we had of the Starlink satellites, and once they get to their operational position. So roughly 6 or so weeks from now, we will have full global continuous coverage of the Starlink constellation, which should really help people that are under or unserved get broadband internet where they can really participate in a digital economy. And digital schooling and digital medicine. There's so many applications for that capability on the practical side. On the visionary, like total space nut, geek out side, of course, is the Starship program. I don't think that people really have even comprehended what that system is going to do for the use of live in, fly through use of enterprise in space. It will be the first fully reusable, operational reusable system, upper stage booster. And when I say operational, we're aiming for aircraft-like operational reusability. And I'm not trying to take anything away from the Falcon and the Dragon team. Those are amazing machines, but this is a leap forward from that capability. It will take people to space. It will take people to other planets, the moon and Mars, of course. We will deploy capability and satellites with that vehicle. The global market for leveraging Starship in point-to-point, just long-haul space traffic, that's going to change. That'll change the world for everybody, having that capability. And I'm sure we'll see good competition, stiff competition there, which we look forward to, of course. And one of the applications, and I know this is hard, and people that know orbital mechanics make fun of me when I talk about this, but I do think Starship is going to be a capability where we can go and pull space junk out of orbit. I know it's hard, I get that, but we've done lots of hard things in the past. And so I'm really looking forward to leveraging the Starship system to go clean up, some of the old carcasses of space debris that are really in the way of a lot of operational orbits, especially those that'll be kind of on the highway for human travel. So yeah, I'm very excited about Starship. So we are headed for our first orbital attempt in the not too distant future. We're shooting for July. I'm hoping we make it, but we all know that this is difficult. But we are really on the cusp of flying that system, at least attempting the first orbital flight of that system. Really, in the very near term.
Well, it was just incredible to see your first landing of that machine, and again, just so inspiring, and something that, had I seen that in the science fiction movie 30 years ago, I would have thought, nobody's ever going to be able to do that.
Right.
And you guys almost make the impossible seem easy, but your processes and your fast forward movement are just incredible. What do you think will be the primary driver for SpaceX in meeting some of these big ambitious goals you've set for yourself?
So, there's no question that Elon sets the agenda for the company, and the technological agenda for the company. And there is almost not a force of nature that is as strong as Elon's vision. He feels in a huge hurry to not just build a capability that will take people to Mars, but build a sustaining capability that will take people to the moon and Mars. And what does that mean? That means it's not one ship every 2 years, right? We have to be able to fly dozens of ships during the time frame when you can get people to Mars. And so it's as much an issue of designing a vehicle that is highly producible. And I know we're building a bunch of Falcon 9s and we're flying a bunch of Falcon 9s, but Starship has to be an order of magnitude or more producible than Falcon 9, so that we can send, many dozens, if not hundreds of ships to Mars as the synodic period optimizes for that. So we know how to build space transportation systems that can get to orbit. The challenge with Starship is is more than that. It's obviously get it safely and reliable to orbit. It's get it safely and reliable to land, as well as be highly producible as well, and operationally reusable. So there's a lot riding on that program. You know, it's just a day in the life. Very long.
Well, for you perhaps, yes. So any previews? Can you tell us about what you're excited about that's coming up in the near and perhaps the long term?
Well, the next big thing for Starship for sure is the orbital launch attempt, which is, I never want to predict dates because we're still in development, but very soon. Very soon. Yeah.
Okay, well, I'm not going to ask about that first Mars landing because I think you're going to get there just as soon as you can, and you prove that every few weeks with the things going on down in Boca Chica. So I just want to thank you so much for making time for us today, and it's been an honor to present you with this award.
Thank you, Rod, and it's such an honor to receive it. Thank you very much. I really appreciate it.
You bet.
Hello, my name is Tony DiTora. I am the Vice President of Policy Coherence and a co-founder of the Beyond Earth Institute. Our mission at Beyond Earth is to create and sustain a legal and policy framework to enable economically vibrant communities of people living and working beyond planet Earth. We generally refer to these economically vibrant self-governing groups as communities beyond Earth. I'd like to introduce my Beyond Earth co-panelists, Steve Wolf, President and also a co-founder, Brett Jones, Vice President for Communications and Digital Media, and Tyler Bender, Research Associate. Steve, Brett, Tyler, welcome.
Thank you.
Thanks, Tony.
All right.
Thank you.
Our topic for this session is Artemis, helpful, harmful, or immaterial to communities beyond Earth. As we look to the Artemis missions and the Artemis Coalition of Nations that has recently expanded, we ask the question, is Artemis going to help enable communities beyond Earth? As we look back at the Apollo program, we can acknowledge that it fulfilled the mission of landing a man on the moon and returning him safely to Earth. And there were plenty of spin-off benefits to American society and to people around the world. But I think it is also clear that Apollo did not enable communities beyond Earth. I have some very strong thoughts about that, but we're here to look forward, not backwards. So let's start with Tyler. Tyler, you've been taking a closer look at the Artemis Base Camp plan. Can you give us a quick summary of that and then follow up with your thoughts on whether the plan, if carried out, is helpful, harmful, or immaterial to communities beyond Earth and why?
Sure. So the Artemis Base Camp is composed of three components. There's a lunar terrain vehicle, which is a non-pressurized rover to get astronauts around the moon. There's also the habitable mobility platform, which is a pressurized rover. And then there's the foundational service habitat, which is essentially what becomes the base camp. But the foundational service habitat is basically a pressurized tin can. So it's good for holding 2 astronauts for 1 to 2 months time, which is a good start because we have I think 16 days total of time on the moon. So it's a good start, but in my opinion, NASA doesn't have much planned as far as what comes after we have the surface habitat.
So we don't have much plan after we land it?
Not really detailed. So Artemis 3, of course, is the mission to return humans to the moon. And that's going to be 1 week on the surface without using the base camp. But by Artemis 4, base camp should be set up so astronauts can use that and start to learn more about living on the moon for more than 1 week at a time. But depending on how NASA plans to build out the base camp, which is they don't have a lot of plans made public right now, I think that's going to determine whether Artemis is beneficial or immaterial. I don't really see it being harmful to establishing communities beyond Earth unless it turns into Apollo where it's flags and footprints and then we leave and then people forget about space for 50 years and then we try again in 2060 or something like that.
Okay. So you said 2 people can stay there for 1 or 2 months.
Right.
And so how often would a trip go to the Artemis Base Camp?
Well, according to NASA's plans now, after Artemis 4, there'll be at least 1 launch per year. So we're looking at 2 astronauts at base camp for 2 months out of the year. So that's something else that NASA needs to address. Can the private sector use the base camp, if they have the means to get there, can academia use it for research purposes? Because if not, we'll have all this infrastructure on the moon that's going to sit vacant for 10 months at a time out of the year.
Wow. So that's quite a thing right there. As we look at Artemis writ large, there's other elements to it. So there's the gateway in orbit around the moon for astronauts to observe the moon, control robotics, perform other tasks. There's also the human landing system, the advanced spacesuits, SLS and Orion, obviously, and the advanced ground systems. And of course, the Artemis Accords will play a large role in how these nations interact with one another, either on the gateway or on the surface of the moon, or as they consider what to do there. So Brett, why don't you share your thoughts about those elements? Which of these do you think could be most helpful for enabling communities beyond Earth?
Certainly. Thanks for that question, Tony. I think having a lunar gateway is imperative for enabling communities beyond Earth. I think in addition to having the surface habitat, having that gateway to deliver materials to other places in the solar system will be crucial to be able to transport materials and humans elsewhere. While the Artemis Accord has an intent for us to get back to the moon with the next man and first woman, I believe communities can be outside of the surface of the moon or other planets. We just saw the release of the Untold Story of Gerard O'Neill earlier this year, that great documentary about the high frontier. And I'm a really big advocate for those O'Neill cylinders and being able to transport lunar regoliths from the surface of the moon into orbit and to create those large infrastructures in space to expand human communities beyond Earth. The surface of the planet might not be the best place for an expanding civilization. So I think having a lunar gateway will enable us to really maximize those resources on the moon and see communities beyond Earth flourish.
Interesting. So Steve, let's turn it over to you for your response to what you've heard so far and your thoughts.
Yeah, I think that we should be very supportive of what NASA is doing right now with the Artemis program. Even though many of us say that, Artemis 3 is returning to something that we've already done, which is flags and footprints, we have to appreciate the complexity of what they're doing. I think that, and the technology that they're employing to do that this time around is much more sophisticated. It is oriented to a degree of sustainability. And I think that where we should be providing encouragement as a advocacy community is the pace at which they're engaging, right? So Tyler laid out a nice scenario where we're looking forward to having one NASA-sponsored mission to the moon a year. Okay, well, maybe we couldn't afford more than that, but what is the commercial component of that? And to what extent is NASA engaging with the commercial community to come along with them to the lunar surface? Now, certainly, we're excited about the public-private partnerships that they are engaging in terms of the lunar, the landing system and other components, robotic components and so forth on the moon. That's very exciting. But when we're talking about the base camp and the HAB, can't we be speaking a little bit more aggressively, a little bit more holistically than just, okay, we're looking to establish these three components as Tyler laid out? Can't we be articulating a larger vision of the embryonic makings of the first community on the moon, and which quite literally is possible? It's not going to be big, not extensive, but if they have one NASA habitat on the moon, why can't we have two or three other private habitats that coexist with NASA? So there's a lot of potential there, and what we'd like to see is a more holistic vision for the future, and not relying on folks like us exclusively or industry. What are we doing? How are we engaging? How how can we, how can we see that fuller picture as we move forward?
Sure. So, personally, I take a look at what at SLS, and I, see the space shuttle, and the space shuttle was an incredibly capable machine, but it was also incredibly expensive. It was also not open for other people. If, say, somebody wanted to purchase a space shuttle to operate on their own, that wasn't available. Could you then turn around and purchase a ride on the SLS? And I'm not sure that they're going to be able to manufacture enough of them, or even open up that possibility as you move forward. So in my mind, that capability will not be enabling. So what other pieces of this, you touched on the Artemis base camp, and Tyler was talking about 2 months out of the year, so it's sitting there for 10 months. Are there ways to enable, because I think the plan, Tyler, and correct me if I'm wrong, is that after 10 years of NASA use for 2 months out of every year, then they're planning on turning that over maybe to commercial entities. Is that right?
I don't think they have really made anything public about what happens to base camp after Artemis is complete.
Gotcha. But they're planning on transitioning to Mars after that, right?
Right, yeah. Because the idea with Artemis is to kind of a testing ground for Mars, but it says explicitly in the Artemis plan to develop long-term exploration and utilization of the lunar surface.
So long-term utilization leads directly to a community. And as Steve pointed out, I think we should accelerate that if we can. I mean, I don't like it's sitting there idle for 10 months if it doesn't have to be. And maybe it wears out half the time, and in 5 years you have to put another base camp down. But I think that would be well worthwhile if we're accelerating our research and accelerating our use of it, and who knows what else is going to come from that. So Brett, as we look at the all of these elements, you talked about the gateway, and robotics is going to be a huge thing as we move forward on the moon over the next decade or so. Can you talk a little bit about your thoughts on the robotics and cybersecurity, about controlling them and those sorts of things?
100%. Yeah, the cyber domain is the space domain. As we saw with the recent launch of the Dragon capsule, it was about this time last year that Bob and Doug flew the test capsule up into orbit to the space station. And then, recently we had the first commercial crew go in the Dragon capsule. It's basically like a giant, Tesla operating system up there. It's got the, iPad surface, tablet surface rather, and, it's touch operated. And behind all of that, you've got the ones and zeros, the bits and bytes operating it all. So, cybersecurity is crucial, not only, here on Earth, but as we expand outward to the stars. And the robotic component is also imperative. I believe the robotic element will accelerate the timeline for us to be able to get human communities built beyond Earth, sending, robots to assemble habitats, 3D printing, base camp before we get there, or other elements. I think that's going to be not only from the physical standpoint of doing the dirty work. I think, it's going to be interesting to see what robotics do with companionship for long-term duration missions. Having a chat bot that is advanced enough to hold meaningful conversations to keep you sane out there. There's so many different ways that we as humans interact with our robots, and I think it will only continue to get more robust and exciting as we continue to expand.
That's a really interesting point. So I was talking to a legal expert about personal cell phones, and I said it's only a matter of time until people start having these things embedded into their skull, medically stuck in there, and then what does that mean for humanity and for everything else, right?
Yeah.
So it's just a really interesting topic there.
Ali Modisette, if you don't mind me expanding on this one, wrote a great book called The Diamante, where he kind of explores the future where there's the regular humans like we are now, the cyborgs that implant, the internet into their brains as the neural link may be possible fairly soon. And then another kind of biologically tuned, spiritual species that figures out how to make the human body like almost like a computer in of itself and just tap into the totality of it. And what those three different parts of humanity, how they work together, and it's a great book. I highly recommend it.
Okay, very good. We've gotten a little off topic now, and Tyler, that's in the Artemis plan, I think.
Yeah, I think the Artemis, you could say, is the start of this transhumanist future that Brett's talking about.
Sure. I mean, if it takes the right steps and it doesn't go the way of Apollo, too big, too heavy, too expensive, good for that specific goal of getting people to the moon and back. And if the goal is to put a woman on the moon and then come back, and then you can do that. But I'd like to shift a little bit, Steve, to the Artemis Accords, because that's also a key component of Artemis. And that sort of interaction between nations. I mean, we obviously have the Outer Space Treaty, which is, developed in a Cold War mindset where nation states are the only actors. But Artemis Accords sort of open up that and expand the understanding of what that Outer Space Treaty means. Can you talk a little bit about that and how that's going to play out towards communities beyond Earth?
Sure. So the Artemis Accords are a set of principles that it was initiated by the U.S. government through NASA and has been offered to the international community as a multilateral agreement. So it's not a treaty. It's not going through the United Nations, but it is definitely a natural extension of the Outer Space Treaty and other space laws. And it's a set of agreed upon principles that the signatory nations agree to abide by, right? And this is what's exciting about this. It means that we're moving forward into space. All nations are moving forward into space, and it's not necessarily a lockstep partnership like the ISS, right? So the ISS was a good experience for sure in terms of international partnership, but we're recognizing that nations may have different ideas about what they want to do or where they want to go or what how they want to develop space, and these principles are a set of agreed upon principles that basically rules of the road, rules of behavior that help to it helps to smooth out the activities. So it might be, such as agreeing to rescue an astronaut that might be in trouble, and so forth. So so that's that's an exciting component. That's an exciting dimension of how space law is evolving.
Gotcha. And then obviously we want standards across the board. Even if people don't sign on to the Artemis Accords like China and Russia, we would like them to engage in similar behaviors.
That's right. So there are about still less than 10 co-signers to the Artemis Accord. So it has a ways to go for broad adoption. But I think whether it is these accords or some other variation of that, as we increase activity in space, especially the human dimension, right? So the accords do cover robotic activities and so forth. That's very, very important. But it's the human dimension, I think, that is going to be particularly important. And we'll need to resolve that. We'll need to have agreements with Russia, particularly with China. Right now China is a bit of a risk. I wouldn't, maybe not an out and out threat, but it's a risk right now that we have to keep a close eye on. So we want to, they deserve to be on the moon as much as we do, and therefore, we need to reach an amicable agreement for accessing those resources and that real estate. So I think that's important.
Okay, I see by the clock it's almost time to wrap this up. It sounds to me like the consensus here is that Artemis could be helpful, though it's not guaranteed to be, but it is unlikely to be harmful as we move towards communities beyond Earth. Do you all agree with that?
Forward progress is paramount.
Yeah. I mean, a couple of things I would say that they need to step up their. We don't want Artemis to devolve into something like the Apollo program, where we're so focused on just getting boots on the moon and getting them back that we start to lose the perspective for the whole moon. Also, one big concern that we have that the Beyond Earth Institute in particular is looking at is the human research program and basically the research that's going on within NASA to help us understand the effects of the space environment on the human body and on human performance. Now, NASA's been doing a lot of great research over the years in this. What is a little worrisome to us is that we're actually seeing, rather than seeing an increase in that kind of spending as we look to go to the moon and Mars, we're actually seeing a decrease in those line items. Which is concerning. There are some areas of research, such as understanding the effects of weightlessness and radiation exposure, and looking at aggressive mitigation events that need far more attention, frankly, than they're receiving. And it's not just about getting to the moon and Mars. It is about a survivability and thrivability of humans for long duration stays, not weeks, not days or weeks, but months and years. And that because that's right where our mission is, and we feel that NASA should have that in mind as they conduct this kind of research.
Great. So as we move beyond flags and footprints to factories and families. So, all right.
Exactly.
Great line, Tony. I'll have to remember that one.
All right. So it's time to wrap this up. Steve, Brett, Tyler, thank you for taking the time and providing your insights into Artemis. I hope we're able to approach the Artemis goals in such a way as to enable and accelerate communities beyond Earth. All right. Thank you all.
Be beyond.
Thank you.
Thanks, Tony.
Okay, I'm Al Globus, and I'm going to talk to you about space settlement. Specifically, when somebody objects to space settlement, they come up with something they don't like about it. Maybe it gives you some tools to answer them and bring them into a discussion that will come out favorably. So if we're going to talk about space settlement, we need to define exactly what we mean by a space settlement. And this definition will last for the length of this session, and then it will go away, and you don't have to use it anymore if you don't want to. Basically, a space settlement is a place outside of the Earth's atmosphere where people work, play, and this is a big one, raise a family. And that puts all kinds of very heavy requirements on the settlement. It has to be suitable for raising children. Okay. Now, one might ask the question, why settle space? Why bother? It seems like a lot of work, which it is. And the reasons are to survive and thrive. Survive, something is going to happen to the Earth sooner or later, hopefully much, much later, but sooner or later, which will make it uninhabitable. And when that happens, we need to have an alternative, be it Mars or free space settlements or on the moon or Alpha Centauri or wherever it may happen to be. Okay? And that's the survive part. The thrive bit is we don't want to just hang on by our fingernails and just barely sort of get by in some awful place. We want to be able to live full lives and have a good time and move around and get and expand and grow and all those sorts of things that mean thrive. Okay? So let's take a look at some of the objections to our survive and thrive strategy. The first objection I'm going to say is space settlement is impossible. You can't do it. Here's talking point one. Space settlement is a massive engineering task, very difficult, but there are no new physics needed. And after decades of study, no showstoppers have been identified. The necessary capabilities are within our grasp. Talking point 2, it is high risk, high payoff. There's a lot, the early settlements may be as bad as Jamestown was in the Americas, where 90% of the population died off in the first year. We don't really anticipate anything anywhere near that dramatic. I think we can avoid that. We know more about where we're going, but there's a lot of risk and people may die. Right? There will be volunteers. Space settlement will be difficult, but the rewards can be enormous. The amount of resources available are absolutely astounding. The resources available are truly enormous. The total amount of energy, the energy budget for this solar system alone, is 2 billion times the energy budget of Earth. Then consider materials. If you take the materials in the asteroids, just the asteroids, no planets, no moons, no comets, no Oort cloud objects, just the asteroids, and you convert them to free space settlements, settlements that are in orbit around planets or moons, you get a surface area equal to hundreds, possibly even thousands of times the surface area of the Earth. Enormous amounts of land, beyond you can even possibly imagine. Next objection. Earth problems must be solved on Earth. Talking point. This is simply untrue. Right? There's just no way this can be right. Let's consider the problem of global warming. We need to understand global warming in order to stop it and retract it and get back to a place where we're confident that the Earth is in good shape. Okay? How are you going to know what the conditions of the Earth are? Well, you take pictures of it with a satellite, with many satellites. And we have Earth observation satellites circling the globe all the time, bringing in data, sending it to Earth, putting it in archives, and giving us the vital information we need to understand what we need to do to keep this planet healthy. That is a Earth problem, and it was solved in part by space. Okay. Now let's take something just more pragmatic. Okay. You're in place A, you're here, wherever you are, you're at your home, and after this talk, you're going to go to Seattle. Okay? How do you get to Seattle? Well, if you know, that's great. If you don't, what do? You take out your cell phone and you program it in, and it tells you how to get there because it knows where it is on the globe. And the reason it can know is because there are satellites in space telling it. Another Earth problem solved by space. Next objection. Tax dollars are better spent on Earth than out there. But here's the talking point. Most resources should and do go to human needs. But a small fraction should go to be our seed corn, to be spent on the future. Consider a farmer, a subsistence farmer. Every year, after they bring the crop in, they have to choose the seed that's going to be used for next year. That's the seed corn. And you take it, usually you want the best corn, okay? That's where you want to take your seed from. So you put that aside and you don't eat it. Even if you're hungry, you don't eat it. Because if you do eat it, there will be nothing to plant. And if there's nothing to plant, there will be nothing to eat. And that will be the end of our farmer and their offspring, okay? That's one issue. The second issue is mature space capabilities often pay for themselves and then some. Consider communication satellites. There was a time when the government spent money to subsidize to get them going. They don't do that anymore. Now those satellites produce more tax revenue than was used to support them in the first place. Okay. And this is because research and development are the seed corn of our civilization. Okay. That's why we take a small fraction of our resources. Consider NASA has got a $24 billion budget, but it's part of the federal budget, which is $5 trillion. Okay? So 24 billion is a lot of money, but it's not a very big piece of 5 trillion. Okay? That's the sort of resources we want to put into R&D. That's our seed corn, to make sure that we'll have something to eat next year. People will damage space as they have Earth. Talking point, that's going to be difficult. Space is mostly rock, radiation, and plasma. Very difficult to damage. Even if you blow it up, it's still rock, radiation, and plasma. Look at, in space, there are no local societies, to oppress. There are no living environments to damage. Okay? There is a pristine environment, and if you believe that everything has to stay the way it is right now forever, well, okay, yes, we're going to modify it. We're going to move things around. But if you observe that life inevitably changes what is around it, a forest changes the temperature of the ground. A wheat field changes the soil that it's in, that it's used. It's a property of life. We change things around. We want to save some things and so forth, but it's a general rule. The rock, the radiation, and the plasma, we can modify, and that's okay. Okay, next objection. Having an alternative devalues Earth. Here's the talking point. Earth is by far the best planet. Hands down, no question about it. The notion that Earth could be devalued by Mars or by a moon or something is ridiculous. Consider, there is no place else in this solar system where you can breathe the air. There is no place where you can drink the water except Earth, our home, the best planet there is. Next objection. Space farming is impossible. A problematic but adequate space farm has been demonstrated on Earth. It was called Biosphere 2, and it kept 8 people alive for 2 years. Okay? Now, they did have to replace the oxygen. They had to bring in new oxygen after 16 months. But still, they made it 16 months, which is pretty good. That showed that the system was completely airtight. They reused the same water for 2 years. Okay? Now, they had an inadequate food supply. They ended up raiding the emergency food. And the reason they had to do that was, first, they did not understand the amount of work and the amount of calories it takes to be a subsistence farmer, which is what they were. They didn't have tractors. They had a half-acre plot, but they had to grow all of their food. Furthermore, the person that designed the food supply had made a career of showing that starvation-level diets increased lifespan, which is great. And the Biosphereans, when they came out, were in peak health. The problem is that when people are hungry and they don't have enough food, they get kind of testy. And there were some interpersonal problems on Biosphere 2. Now, it should be noticed that all the problems, the problem with the oxygen and the problem with the food supply, were solved the second time they ran Biosphere 2. They only made it 6 months. It was a management mess of epic proportions, and that was the end of Biosphere 2. But it did show that space farming is probably possible. Next objection. Human beings cannot tolerate space radiation. Well, that's absolutely true. They can't. That's why you need radiation protection. You need radiation shielding. And that's our talking point. Settlers can be protected by radiation shielding. Now, there's 3 kinds of radiation we're really concerned with in space. One is solar flares, solar storms. They can kill you in a few minutes. They're very intense. They're not very often, and they don't last very long. So what it means is when you detect a solar storm coming, which we can, you won't have a lot of notice, but you'll have some, you have to get into a shelter specifically designed to keep you alive through a solar flare. Okay. The second kind is radiation trapped in Earth's magnetic field, and that's very easy to avoid or just pass through quickly and you'll be fine. The last one is the one that causes most of the problem, and that is galactic cosmic rays. Galactic cosmic rays come from every possible direction. They're omnidirectional. They come at many different energies, many different sizes. You can stop that GCR with enough material. Now, if you're on the surface of a planet or moon, you require 8 tons per meter squared of regolith. Regolith is just like on Mars or the moon. Or 5 tons per square meter of water. In free space, remember, you don't have, on a planet, half of the GCR is blocked by the planet itself. In free space, you don't get that. So it takes 11 tons per meter squared of regolith and 7 tons per meter squared of water, which is a lot of material, but that's something that we can do. We can design bulldozers. Next objection. People cannot tolerate weightlessness. People can tolerate weightlessness for a while, but not for very long. After a half a year, 6 months or a year, people pretty much need to get back into an environment where they have some gravity. But here's the talking point. Free space settlements can provide artificial gravity by rotating. And it can do it any gravitational level you like. You can get 1G as if you were on Earth, so your kids will grow up with the same sorts of bones and muscles that they are growing up with now. You can have it be at 1/3 G that match Mars. You could adapt over a period of time. Or it could be 1/6G, which is lunar levels, and so people could be prepared for that. Basically, the problem can be solved by rotating. Not that hard. Next objection. People may not tolerate lunar or Martian gravity. Talking point. We have no data on the effects of reduced radiation on children at all. None. A spinning facility, a rotating facility in low Earth orbit will be needed to resolve the inevitable issues. In particular, to be able to do plant experiments and be able to do experiments for short periods of time with people and building up the different rotational rates, different gravitational rates, a whole research program to get to the point where we can say, yes, we can bring our children, they can live at 1/6G or 1/3 G, and they'll be okay. Or we can say, no, this isn't going to work. This is not something you can do to kids. Next objection. Free space settlements will be hit by asteroids. The talking point is asteroids big enough to be dangerous are rare, and they can be deflected. Or you can move your space settlement. Asteroids hitting Earth we know is a serious problem. But if a space settlement is considerably smaller than Earth, it will be hit much less often. On the other hand, a smaller object can do more damage. If you have a 10-meter object that crashes into Earth, unless it hits in a city, it won't do that much damage. If it hits in a settlement, that'll be the end of it. But we are already developing a system to find and track and know where all the dangerous asteroids in our solar system are. And we are doing experiments to see how we can deflect asteroids. So once we see them, we can do something about it. This is something we're going to have to do forever. There will always be one more asteroid that we have to keep track of. But on the other hand, it will reduce the probability of us being exterminated by a large factor. Next objection, there will be war in space. Well, I'm not willing to give up on the notion that that's inevitable, but it's likely. There are certain classes of wars that won't happen or shouldn't happen very much. Talking point one, resource wars are less likely as the readily available resources are so enormous. Remember, 2 billion times the energy budget of Earth, sufficient asteroidal material to build land equal to hundreds, possibly even thousands of times the surface area of Earth. The second point is that free space settlements are definitely fragile, very difficult to defend. And this will limit some classes of warfare because the free space settlements just won't get into it. They're too vulnerable. Next objection, dictatorship may be developed. That is something we see happening on Earth, literally before our eyes, and it is a problem that we're going to have to face. One approach to that problem is identify the minimum number of rights you need in order to be able to avoid dictatorship and find a way to provide those. I think, and others have thought before me, that the only right you have to have is the right to leave. A problem with that is you really need it, and it's very difficult to guarantee. So we'll keep looking into this. Next objection, rebel space settlements may attack the Earth. Talking point, the Earth needs to know when to let go. By far the most likely reason for the space settlements to attack Earth would be to gain their freedom. And so if we provide it, the English didn't provide that in the Americas, and there was a bloody war that went on for years, made a total mess of things. Okay? But since then, Canada, New Zealand, Australia, South Africa, they all became independent peacefully. So that's the model we want to follow. Last objection is the danger of alien encounters. Now, I'm not a big fan of alien stuff, but something really gives me pause. It is estimated that the total number of planets in the habitable zone of this galaxy is on the order of 300 million. So if you have 300 million with the right stuff to hold life, and you know that at least one of them became spacefaring. That's us, okay? How can you say that it's not likely that there are 2 spacefaring civilizations or 3 out of 300 million? You can't say that. You have to deal with that. Okay? Now, the problem is if those aliens are capable of space travel, of moving from one solar system to another, then we are way behind them and we don't stand a chance in a fight. That means we have to hope that they are nice aliens, if you will. And they may be or they not be. We aren't. Right? So that's a bad sign. But given time, if we can build out and work our way to many solar systems and become strong, maybe we could survive an encounter with an alien civilization that was not nice. Now, if the alien civilization is nice, okay, just don't piss them off. We don't want that. But so there's a temptation to hunker down and hide. The problem is that ship is gone. We have already been sending radio signals and TV signals and radar signals out into space for decades, saying, here we are, here we are, here we are. So we better hope that they are either nice or don't hear us. In short, there are many potential objections to space settlement, but there are valid responses to each of them. While some responses are more robust than others, the evidence points to vast benefits from our expansion into space. Talk openly and intelligently to the doubters, for it's time to begin our greatest journey yet, our expansion beyond the home planet. Those are the words of Rod Pyle that he added as editor, and they are very true and very good. Thank you.
Space exploration is one of the most difficult science and engineering challenges that humanity has in front of it. In order to achieve this grand challenge, in order to even come close to meeting it, we need the talents, experiences, and cultures of people from all over the world.
There are now starting to be a lot of careers for young people who are going into college or graduate school.
If space tourism takes hold, it's the hotel industry, but in a unique environment.
There is a great need for young people coming into these fields because that has not been happening actually for a couple decades now.
Space exploration is more viable today than at any time in history, and the private sector is showing us how to get into space.
SpaceX has really shaken up the industry in the past 2-3 years or so, and by bringing this intense competitive edge that they have.
We need more scientists. We need more people who see science as an inherently vital part of our success as a species on this earth, of our ability to overcome any challenge that nature, that the universe might throw at us.
I would encourage all young people who are interested in being part of this renaissance in space exploration to follow their hearts. There are all kinds of jobs that are going to be available in aerospace in the coming years, in the near future.
Follow your passion, and then there'll always be an opportunity to tailor whatever you're interested in. You'll find a way to adapt that to an interest in space.
It's much more likely these days that if you have a specialty in biology or pharmacology, you could become an astronaut payload specialist or a mission specialist, actually fly on the space station, or fly with a commercial company to develop new stem cells or new protein crystals that could cure cancer.
Follow your dreams, dream big. Don't worry about what people think about your dreams or what they say, because if you are passionate about it and you are committed to them, you can make big things happen.
It could happen at any moment, anytime, anywhere. And the results could be devastating to all life on our planet. The solar system is a shooting gallery. Earth swims in a vast swarm of rocky objects, the debris left from the formation of the planets. Some are small, some are large. And while we try to track the most dangerous of them, many drift through the darkness undetected, with some passing dangerously close to Earth. But even if we spot a large asteroid headed our way, we are not at present prepared to do anything about it. We would be forced to watch it become ever larger in the skies, potentially ending us all. We all saw the effects of the rock that exploded over Russia in 2013. That one was small by cosmic standards, just 60 feet across. A larger 500-foot object struck Siberia in 1908, destroying everything within 800 square miles of impact. It will happen again, and the next one could be even larger, endangering everyone on our planet. Detecting these threats is the first step. We need the instruments that can spot them, and we need time to prepare a response that could save us all. As you watch this, there are over 1 million chunks of rock and ice 50 feet across or larger that could endanger the Earth. Observatories scan the skies for objects that may pose a threat, but are limited by the obscuring blanket of the Earth's atmosphere. We urgently need space telescopes placed high above the atmosphere to spot these intruders. These orbiting sentinels will use cutting-edge infrared technology to identify fast-moving near-Earth objects with unprecedented precision. Because when dealing with Earth-endangering asteroids, there are no second chances. Your support is critical to protecting Earth and everyone who lives here. Your donation in any amount will help the National Space Society to encourage Congress to support this urgent priority. This includes the Near-Earth Object Surveillance Mission for asteroid detection and the DART mission to test asteroid deflection. Both are critical to protecting Earth. Because our planet and everyone you know and love are in the crosshairs. The time to act is now.
We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Indicate chute deploy.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
LVS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
Back shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
TRN Safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
NASA's Perseverance rover has been working on its science mission with the help of the SuperCam instrument, a rock vaporizing laser and camera that examines rocks and soils. To learn more about SuperCam, we are joined by Hamani Kalucha. She's the science payload uplink lead for SuperCam operations.
So SuperCam looks out of the big circular window in the white box on top of the mast, and it uses spectroscopy, which is just when light excites atoms in a rock and we get unique shifted wavelengths back to us. And so we use a combination of lasers and infrared vision, and that lets us do science even further out than the robotic arm. The lasers reach 7 meters or 23 feet away, and the infrared much, much further. And that's not even all. We have a tiny high-resolution camera and a microphone to hear Mars. And that's how we heard the helicopter.
And can you talk about some of the images SuperCam has taken and why they are important to scientists?
Absolutely. So we started by taking out images and spectra near the rover. And as you can see in this image, the laser actually blows away the dust and makes these small pits in the rocks. And that lets us analyze material that's just below the surface of the rock, which is what we care about. And then we can record the sounds of the laser with our microphone. And it tells us something about the hardness of the rocks. And then starting Sol 26, we were able to take pictures of these long distance targets like Kodiak. And that really helps the rover team understand where to drive next for more close-up analysis. And these red circles you see is actually the infrared telling us about the mineral content of these faraway outcrops. So that's how SuperCam figures out more about the geological history of Mars. And we're so excited to see what the laser can do next.
Thank you so much for joining us today, Hamani. To get the latest updates, follow at NASA JPL and at NASA Persevere on social media. And on the mission website, mars.nasa.gov/perseverance, you can also find all the raw images being sent back by the rover.
Welcome back, everyone. We're very happy to be at the Jet Propulsion Laboratory in Pasadena, California to give out a couple of very special awards today. I'm talking to Dr. Bobby Braun, who was instrumental in the entry, descent, and landing profile for a number of Mars programs, starting with Pathfinder and going on all the way through Perseverance, correct?
Yep.
Yeah.
Been involved for a little while now.
Which is some scary stuff. So we have here the Space Pioneer Award. And it says, for science and engineering presented by the National Space Society to Dr. Robert Braun, Director for Planetary Science, NASA JPL, for the discovery and solution of the Mars EDL entry, descent, and landing problem.
Wow.
So congratulations.
That's amazing.
Thank you for your work. You've made a lot of sensational things possible, and we're really very pleased to give you this.
Well, thank you for this award and for the honor. It's amazing, actually. I should point out that there is no individual that actually is responsible for solving the EDL challenge.
Right.
There's a great team of people across the nation, actually across the world now, that have devoted their lives to working on this problem, and it's really through all of their combined efforts that we've been able to go from Pathfinder to Spirit and Opportunity to Curiosity and Perseverance, and to eventually Mars sample return and humans exploring Mars. But on behalf of all those folks who I consider my friends and colleagues, this is a great honor, and I'm happy to accept this. Thank you.
You're very welcome, and if I come across a pot of gold doubloons somewhere, I'll get trophies for the rest of your team. But for now, we've just got the two. So you can put that down if you want. They're kind of heavy.
Oh, it's too good to put down.
Okay, well in that case, hang on to it.
I'll put it down right.
So let's talk a little bit about your career path. You started working on this particular part of what you do, EDL, back with Pathfinder, correct?
Yeah, actually, the very first problem I worked on when I graduated from college and was hired at the NASA Langley Research Center was how to land humans on Mars. And that problem, didn't have an application, an immediate application.
Yeah.
And so I took the work I had been doing, and in the early and mid 1990s, I started applying it to robotic exploration. And Mars Pathfinder was the first flight mission that I contributed to. And I was a part of the Mars Pathfinder team almost from the beginning all the way through the flight and the reconstruction of that data. And there was nothing better, frankly, for a young engineer to be working on than Mars Pathfinder. It was a great team, a great accomplishment, and of course, through our landing success, we put down Sojourner, which was the first Mars rover.
Right. And I remember seeing video of that at the time, thinking, man, it looks like these guys are having a blast.
We did have a blast.
It looked very informal. It looked like it was delightfully fast-paced, and yet there were a lot of smiles on that mission.
Yeah, it was the kind of project, we were all too young and naive to know that we couldn't do it.
Right.
So we just made it happen. And we worked really hard. We worked around the clock and for many years. But it was like a family environment. Many of us were young, getting married, having kids at around the same time, and we knew each other through work, but also socially. And frankly, I'm still close to almost everyone that I worked with on Mars Pathfinder. I still talk to them regularly. One of these guys is right here, even.
And we'll be talking to him too. So at the time that you got engaged with this, we had only landed 2 spacecraft on Mars, both the same way, Viking 1 and Viking 2. We had seen the Soviet Union land sort of successfully once, but it didn't operate very long. So that was your point of departure, I assume, for what you were trying to figure out, correct?
Not exactly, but yeah, so Viking, of course, was the first 2 landings on Mars done by the U.S. in the 1970s, right. So 20 years before Pathfinder.
Right.
I should point out, when Viking landed, I was 11 years old, and I grew up outside the Goddard Space Flight Center in Rockville, Maryland.
Yeah.
And I got to witness the Viking landing, which impacted me greatly as a young boy. And so to get 20 years later to follow in the steps of these giants that I had watched, create Viking. So Viking was a tremendous mission. And in fact, when the folks at JPL came to NASA Langley looking for some help with Mars Pathfinder, they were actually coming to find some of the Viking people, because Viking had been managed at NASA Langley.
Right.
And because 20 years had gone by, instead of finding the Viking crew, all they found was this young kid that was doing computer simulations of EDL. And they asked if I wanted to help with Mars Pathfinder, and I, of course, jumped at the chance, joined the team, and we went forward from there. Now, the big difference between Pathfinder and Viking is that Mars Pathfinder was being done on a shoestring budget, right. And in much less time than Viking. And so we had to invent a new way of doing entry, descent, and landing. And that included the first direct entry, right? Viking
Right.
went into orbit first, and so it deorbited and entered the atmosphere at a lower speed with less stringent heating and less significant heat shield than we had to have for Mars Pathfinder. And then we didn't have the ability to have a propulsive descent stage. So after the parachute, we had to invent a way of soft landing.
And your solution was novel, to say the least.
And the solution was the airbag approach that we applied on Pathfinder, and then again on the 2 Mars Exploration Rover missions, Spirit and Opportunity.
Right. So you used that for 2 missions, 3 spacecraft successfully. And then when the time came for Curiosity, you had to change that because, I assume, of mass?
Yeah, so what you need to realize is that every one of these Mars missions is a little bit different because the science that's driving the missions is different. The science of Pathfinder and the science of Curiosity or Perseverance, they're both at Mars, but they're very different.
Right.
And so the requirements on the rover are very different. The size and the mass of the rover, which is the payload for the entry, descent, and landing system, is very different. And if you go from a rover that's the size of a little baby, the Sojourner rover, to the size of a car, then obviously the system that lands it has to grow and scale. And you can only scale these different technologies so far. You can only take airbags a certain distance. You can only make, frankly, parachutes of a certain size that still deploy, that you can still test on the Earth to deploy supersonically. And so as the science changes and the payload for the entry, descent, and landing system changes, so does the design itself. And so we actually tried for a while when we were doing the conceptual design of Curiosity to try to make the airbag system work, and there was just no chance. And so a whole new concept had to be invented, and that team came up with the sky crane approach, which was applied successfully for the landing of Curiosity, and then improved upon for the landing of Perseverance, which was slightly higher in mass, but landed much more accurately than Curiosity. In fact, without the improvements that we made between Curiosity and Perseverance, Perseverance couldn't have been targeted for the spot that it is now, which is, you know, the science sweet spot where we're interested in caching samples and one day bringing them back to Earth.
Yeah, because your landing ellipse for Perseverance was tiny in comparison.
It was tiny, and actually it was on the order of 8 kilometers in major axis. But within that 8 kilometers, we had the ability to target one of hundreds of safe zones that we had identified a priori and actually fly to that safe zone. And each of these safe zones were on the order of the size of a football field. So in essence, on Perseverance, we could land in one of hundreds of football fields that were dispersed over this small region in this incredibly difficult place to land otherwise. There's no way that we would have attempted a Pathfinder or even a Curiosity landing in that location. And in fact, if you look at the data from Perseverance, as we were coming down on the parachute, and we have imagery of this for the very first time, you can see that the rover is headed towards a spot that was marked as hazardous. And very late in the game, the terrain relative navigation system detects that, and it commands a propulsive maneuver to move to one of these safe zones. And that works successfully.
So that's during the powered descent part, right?
It's all autonomous, and it was during the powered descent part, yeah. There's no ability, given the distance between Earth and Mars, there's no ability to joystick that from mission control. What we're actually watching when we're sweating this is we're watching events that have unfolded, 10 to 15 minutes a priori that we get the signal. We're just living it, in the moment.
So it feels like it's real time.
Oh, it definitely feels real.
There's a little part of your brain thinking, I hope this was a poof and not a splat. So looking ahead to human landings with bigger, much heavier spacecraft, how do we think that's going to be accomplished?
Well, we're working on that, actually. And it's something, frankly, that I've been proud to work on for multiple decades. And I'd like well, I'm happy to report that if you had asked me that question a couple of decades ago, I would have said, I have no clue.
Right.
But today, I can say that I have a sketch of an idea for how that's going to work. And we certainly haven't proven that the approach that we have in mind for how to land humans is exactly right. We have a long way to go to prove all the requisite technologies and get them ready for spaceflight. But I would say that the laws of physics actually, we've proven, permit landing humans on Mars. And so we know how to do it now. We just have to prove the technologies, get them ready for flight, and go. The other thing I'll say is that the way we're going to land humans on Mars is going to look nothing like the way Perseverance or Curiosity was landed, just like Curiosity and Perseverance looked nothing like Pathfinder, and Pathfinder looked nothing like Viking, right. Before it. And that's because technologies are advancing all the time, and we frankly need these new technologies as the landed mass goes up, as the need for accuracy improves. Right? When we land humans on Mars, we want to land them in a specific spot that's probably been prepared in advance by robots, packed down. You know, think of it maybe not a runway, but think of it as a zone that will be cleared of debris for that landing. We're talking about landing not 1 ton of payload, but perhaps 10 or 40 tons of payload per human craft. And so that's a very different ship with very different systems. You know, it's probably, I mean, parachutes probably don't work for that system. So we need a new way to decelerate supersonically. There are a couple ways that are being considered now, like the use of propulsion, supersonic retropropulsion, the use of different types of decelerators, like those that inflate or deploy to create more drag area. And these are like stronger technologies. So the community's working these systems really hard. There's also some heat shield challenges and some GN&C challenges that are specific to human exploration. But we know the set of systems that are needed to accomplish this. And if we were given the chance and, you know, 5 to 10 years to get ready, I have no doubt we could achieve this.
We like to hear that. Speaking of being given the chance, we have a wonderful rover up on Mars right now, which is soon going to be taking small core samples and caching them for return to Earth. And we need to get them back here.
Yeah, we do.
So how's that going to happen and when?
Wow. So
look at your crystal ball.
Well, actually, I don't need to look at my crystal ball because we're actually working on that today. So while Perseverance is roving the surface and Ingenuity is flying overhead, and while Perseverance goes through its caching mission to grab just the right samples, contain them, seal them, and place them in caches for later pickup, we here at JPL, with our partners in Europe and actually partners all around the country, are working on the next set of flight systems that will go get those samples and bring them back to Earth. And the way that mission or that set of missions is going to unfold is there'll be a landed mission that will land about 1.5 to 2 times the mass of Perseverance. And that lander will contain a small rover that we call the Sample Fetch Rover and an ascent vehicle, a 2-stage solid rocket system that's currently being designed and developed by the Marshall Space Flight Center. And that Sample Fetch Rover, which is being developed by the European Space Agency, will go out and gather the samples that Perseverance has placed on the ground. We also have the ability, should Perseverance still be alive, and I think it will be in about 7 to 8 years when this mission is on the Mars surface, we have the ability for samples to come back directly from Perseverance. So those 2 rovers will go out, they'll get the samples, they'll bring them back, and they will deposit them in a container that can hold up to about 30 sample tubes. That container will be sealed hermetically on the Mars surface. It'll be brazed, meaning at high temperature it'll be sealed again.
Wow.
And then it'll be placed in the nose of that launch vehicle, and the launch vehicle will lift it up into Mars orbit, where that container will orbit Mars. A second mission, which contains an orbiter, which is an orbital mission being developed by the European Space Agency, will fly out to Mars and rendezvous with that orbiting sample, and then gather the sample and place it through a series of mechanisms being developed by the Goddard Space Flight Center, and place that sample in an Earth entry vehicle before the orbiter does a return trip to the Earth, letting go of that Earth entry vehicle at just the right time, at just the right attitude, for it to fly through our atmosphere and land safely in a contained area out in Utah, actually. And so this will be humanity's first round-trip mission to another planet, which I think is just fascinating, right? We've, of course, had round-trip missions to the moon, We've had robotic sample returns from other destinations through a comet tail. The Stardust mission, the Genesis mission returned samples of the solar wind. But to actually land on a planet and bring things back from that planet to the Earth, that's something that is, of course, it's scientifically valuable, but that's something we have to prove before we send humans to Mars anyway. So this will be our first round trip.
Well, I think you kind of touch on something there, talking about bringing back samples from another world, another planet. There's something special about Mars. And you read people in their writing, trying to qualify that over the years. I mean, it's a planet instead of a moon, which is, I think, notable. It's not an asteroid or a comet. It's not a little rock. It's not Venus, which is kind of this, as wonderful as it is scientifically, it's kind of a trailer park. So it's this place that we've been thinking about and obsessing about for at least a century.
That's right.
In terms of being a planet, a place we want to go. And so I think, being able to accomplish that first sample return is going to be an incredible achievement. And I expect to be giving you another one of these when you guys complete that, because that's going to be just sensational.
Having the samples back will be a trophy enough, if you will.
I'll trade you.
But this is something that we're going to be working on around the clock in this decade, and that we think that we can pull this off, by the early part of the 2030s. So if you were to come back 10 years from now, 2031, I think this will be happening. Mars is also special, I'll point out, because we know it was warmer and wetter in the past. Around the time that life began on the Earth, we know that Mars and Earth were very similar. And so there's, some pretty fundamental philosophical questions there. And Mars is also a place that we know is in, humanity's destiny. It is a place that you can imagine one day, very far in the future, you can imagine living off the land in a place like Mars. And over time, transforming it into a place that is suitable for human explorers. And so bringing samples back robotically that not just tell us about science, but inform us about that future is incredibly important. And I'm just thrilled to be a part of that endeavor.
Well, we're obviously thrilled that you're a part of it too, and thank you very much for your work and your contributions.
Sure.
And for joining us here today. It's been a real pleasure.
Thank you, and once again, thank you for this tremendous honor. I'm incredibly, I'm blown away by it, and I just want to thank everyone at NSS for thinking of me. Appreciate it greatly.
Great. And what he really means is join the NSS, and if you are already a member, renew.
That's right.
Thank you very much. It's a real pleasure.
Thank you, Rod. Great to see you.
Welcome, everyone. I am Janet Ivey, and I am a proud member of the Board of Governors for the National Space Society since 2014. Also, currently, I am serving as president of Explore Mars, and it is my pleasure and privilege to be here and talk with you guys a little bit about what we're doing at Explore Mars, how we are hoping to partner more with the National Space Society. I hope some of you got a chance to watch our Three Presidents Town Hall. Jeff Notkin interviewed myself. Jeff and I actually became a member of Board of Governors at the very same time. And then as Michelle Hanlon was coming on and becoming the president of National Space Society, she and I have exchanged several emails, and we're not quite sure what we're going to do, but we have made a vow that we are going to work together in collaboration with Explore Mars and National Space Society, something I'm very, very delighted about. I want now to introduce to you probably someone that doesn't necessarily need an introduction. He is the CEO of Explore Mars. It's been my privilege to serve alongside him for these last 2 years, and his name is Chris Carberry. Back in early 2000s, he was also a board member for the National Space Society, so we are indeed among friends. Chris, why don't you tell everybody about what it is we do and our kind of passion and our mission statement of Explore Mars?
That's a big question. That's a
Sorry, Chris, come on.
Well, I think most people know our biggest event of the year is the largest annual Mars conference in the world for getting humans to Mars, the Humans to Mars Summit. And we have that coming up, excuse me, in September, which we're going to announce some details of it very soon. It's probably going to be a private, not private, now I'm screwing up as well. Let me start again. And I'm coughing on my dinner here. It's like,
oh no! All right, so I will introduce you just a bit again. So here is my friend Chris Carberry, the CEO of Explore Mars, to tell us a little bit more about our advocacy that we do, about the programs that we offer, and a little bit about our mission at Explore Mars.
Thank you, Janet. And as you mentioned, I'm also a former NSS board member, and I have fond memories of going to a couple of board meetings at the old X Prize Cup in New Mexico back whenever that was, probably 2007 and 8 in that time frame. A lot of fun. But anyway, Explore Mars, we were founded in 2010. Since then, I think we've been certainly the leading advocate for Humans to Mars for a nonprofit. And we run the Humans to Mars Summit each year, the largest annual conference focused on getting humans to Mars. And the next one's in September. And this one's going to be kind of a hybrid event. We're going to be partially virtual, but we're also planning an in-person element. We're going to announce details of this very soon. So we're hoping that the National Space Society will be able to partner with us in some way or another. We hope to have some NSS speakers there as well. So it'll be fun to do that and then work with NSS moving forward when we get back to our conference in Washington, D.C. in 2022. But one of the events that we just got finished with, which I thought was really exciting, was last week. We completed our Mars Innovation Forum. This was an event where we didn't necessarily focus on the big rocket companies, but all these companies around the world, they're trying to find ways to create sustainability on Mars. How do you eat? How do you breathe? How do you communicate? How do you remain sane? And the things that don't necessarily cost billions or hundreds of millions of dollars and aren't necessarily the big aerospace companies. So that was a really interesting event. And that's going to be an ongoing series for the next few years. But of course, we also do a lot of STEM education work. So why don't you tell us about some of the STEM education work that you've been leading?
You know what? It is, everyone knows that's my heart and passion. And, certainly what we've seen in the last 15 months is a lot of flexibility and shifting. So even education has gone virtual. So partnering with Explore Mars, we have, reached over 8,000 kids in Zoom. That's been me and kids in Zoom over the last 15 months. We've reached over 200,000 kids asynchronously. And Aggie and Aaron are due in large part to a lot of that outreach through E360 television. So I'm indeed grateful for that. But our whole idea was how do we take and do this and get it to as many kids as possible. I was operating with the NASA Next Gen STEM grant, Explore Mars. Anytime I said, hey, let's go do something outreach, and it's like they were right there alongside. But our big mission is just simply to get this generation thinking about, what kinds of jobs they're going to be when we realize that the space industry by 2040 is going to be $1 trillion or trillions of dollar business, that for kids today, we need to start prepping them that learning how to think about feeding Mars or AI and 3D printing habitats is, perhaps even the name of the business they'll be in. That title hasn't even been created yet. So,
this is a very exciting time for kids to be growing up. Very exciting time for adults to be growing up as well. I mean, it looks like we're probably going to have probably the golden age of space exploration starting basically now. The 2020s look like they're going to be extraordinary, probably surpassing the achievements of Apollo, probably by a lot, with all the different activities going on and hopefully getting to Mars by the 2030s. So a lot going on. As you mentioned, it's not just, you don't have to just be scientists or engineers anymore. Those are important, but pretty much every sphere of society has something to contribute. So it's a really interesting time to try to tell students this, that show that they can be part of this, even if they're not studying, mathematics or engineering. If they go into law, well, there's an awful space law is turning into a huge business, and so many other areas of civilization are going to come into play within the space realm.
And it's quite exciting. And that's, to have Michelle Hanlon, who herself that is her whole work is about space law, and to see how we're going to behave as humans going out there, and hopefully we can do so peacefully and collaboratively. And hearing last week some of the amazing innovations. It's like, Vint Cerf, the father of the internet, basically gives our audience this sort of dictum to go out and can you guys solve that faster than light problem that we have?
Wouldn't that be nice?
So kids, if you can solve that one. And hearing from people from around the globe going, I don't want to go to Mars if I can't have chocolate. Or how do we keep our bodies healthy and safe as we do long-term missions? And so it's no longer fiction or science fiction. It's not the future. The future is now. And space certainly isn't the final frontier. It is the next frontier. And that's why we're so excited to just say hello to everyone here at ISDC. And we just want you to dive deep, become part of the community. If you're a first time, perhaps this is the first space conference that you're tuning into, or if it happens to be, hey, I've gotten really used to joining all of these great offerings that happen virtually. Welcome. I think whether it's Explore Mars or National Space Society, our big thing is we invite you to become a part of this fantastic adventure. And, so many people have said that it's like it was the Apollo moment that made them want to explore, or made them think about space and the moon and Mars. And pretty soon, this generation is going to have their Artemis moment. And as Chris was saying, I believe it will be kind of the golden age of space, the biggest space renaissance we've ever seen. And I'm just waiting for my flying car, Chris. Can you
It is just the beginning. And absolutely. So thank you for having us speak at ISDC. If you want to learn more about Explore Mars, pretty easy. Just go to exploremars.org. And we would love for you to attend one of our events. And just like ISDC, we love to have volunteers. So if you want to get involved with the space community, yeah, absolutely. We're welcome to, would love to have you, as I'm sure NSS would love to have you as well.
Thank you guys so much. And again, consider becoming a part of the NSS and Explore Mars.
From this distant vantage point, the Earth might not seem of any particular interest. But for us, it's different. Consider again that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines. Every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust, suspended in a sunbeam.
All right. Good day, everybody. My name is Lorna Jean Edmonds, and I'm a National Space Society board member and one of the co-founders of the space policy and universalization debates that are hosted by the NSS over the past couple of years. And it's about promoting students around the world to be engaged in the future of outer space and its impact on the world. As you know, the National Space Society is an organization committed to bringing social change, technological development, excitement to the development and expansion and settlement of outer space. And part of that is our curiosity of how we go about that and what are the things that we need to be thinking about in terms of the future of our world within the universe. Part of NSS, which is also an exciting part of today, is to celebrate the leaders who are evolving and growing our understanding of this next frontier, one of the fastest growing frontiers in the world at this time. And it is my pleasure today to speak about this individual, Mr. Isaac Arthur, who I have the pleasure of granting him the Space Pioneer Award that was awarded to him in 2020. This award is about individuals and teams who have opened the space frontier in everything from business, science, art, education, service, and government. But Isaac, if I can use his first name, is the founder and producer of one of the fastest growing YouTube channels in the area of science and futurism. And this one channel is now allotted to hear people watch from over 650,000 people from all over around the world, I believe, Isaac?
Yes.
It's a channel that offers us one of the most impactful and, might I say, accurate perspectives on science and the future of our world, extending to space, ranging from astronomy and aliens to biomedicine and basic science to the Fermi paradox, which I might ask you to define for us at some point, and most importantly, the future of spacefaring civilizations. With a stellar background in physics right down to his genetic makeup, and a vast international technical and advisory team, he has created for us an amazing, accessible, informative, and extremely interesting program with perspectives and insights well worth watching. So over to you, Isaac, to shed some light on the story behind the making of your production, of your vision of the science and futurism as you see it today. So why don't you give us a bit of context?
Well, I guess as a rule, the show's mostly about kind of the idea that all the areas of science and art that tend to go into the future tend to get feedback off each other. We get so many of our new scientists from one seeing science fiction or being inspired by a bit of art, who then goes on to be inspired by some new bit of science. And so we tend to embrace our sci-fi as well as our design roots in terms of trying to get that feedback of building up public enthusiasm while at the same time trying to feed up all new scientists on just knowing how fascinating the universe is. So the show tries to encourage everyone to just love space and love the universe, and it's such a wonderful, amazing thing that it's honestly not that hard to write about. Fortunately, over the years, I've had a lot of folks who part of the audience have joined in as volunteers to help out on writing, editing, doing graphic animations. There's so many beautiful animations that have been done for the show by volunteer artists, and I can never thank them enough because they're usually the first one illustrating some of these concepts, some of these giant structures we might build in space. And it's just wonderful to get to work with those folks. They inspire me, and apparently I'm lucky enough to inspire them and others. And it's just been an amazing 7-year ride so far.
So why don't you tell me a little bit about your team? Because I know it's pretty vast and pretty global and pretty dynamic, and it's kind of everybody's engaged from what I can understand.
It's very fluid. I mean, at some level, we have, I think, 50 or so moderators just for our social media who come and go with time. And we've got other folks like Jacob Greiger, who's out of Poland. He is used to work for Marvel movies in the cinematic universe, and he does our covers right now. He's been doing them since, I think, episode 20, and we'll approaching episode 300 very shortly, and he just does beautiful designs, and he's the first member of our team. And then we've had so many folks who have come and gone over the years as time permitted. Mark Warburton, Jerry Gorn, Tiffany Penner. There are so many people I couldn't think I could even name them all. Naomi Cohen, I'll give it a try real quick. Keith Blockus, and there's just so many, and it's such a great honor to work with them all. So Alex, Jason, all the other ones, thank you so much for all your help. This award is a lot more you guys than mine, to be honest. And it's been a great pleasure to work with you, and it's been such a great time to get to learn along with you and to make these episodes with the public. And it's been so great to get that feedback from the public. So it's a very different than the old school of writing, doing show production, where you might get to run into your audience and hear feedback, years down the road from when you made something. Nowadays, you can get it pretty much live, and it's quite staggering sometimes, but also quite it's a wonderful feedback process. It's quite inspiring.
So here, why don't you just give us back your award so we can all have a look at it for a moment, because this is the first occasion where I feel like I'm handing it to you virtually, because we had to send it before, but it's pretty impressive. And again, your program is incredibly impressive. What do people say about your program? What kind of feedback do you get?
Well, feedback comes in every type of form. Sometimes we're very lucky. We get very little bad feedback, to be honest, compared to a lot of other shows, even the sciences. A lot of my peers who do science shows in YouTube and the other formats still get fairly vicious remarks compared to what I do, and yet it's still generally a lot cleaner than we expect from the internet. But I would say 99% of our feedback is positive, and it is a good way to start the day sometimes, just to read those comments and say, what's happened with them. I think my favorite ones this day are always when someone says, I watched this with my kids, or watched your show and it inspired me to go into the field and study. It's not always physics. Sometimes it inspired me to go into the field of biology or geology, but it inspired me going to astronomy, inspired me going to rocket engineering. And sometimes the best ones are someone you hear back from 4 years afterwards and say, I just finished getting my degree and you encouraged me to go into the field. And there's other folks who have written books and said, we got plot ideas from the thing, or we, so much of the setting or world building we did for this fictional story, or this TV spot, this book was inspired by the show. And those can really give you a bounce. That sort of thing that puts a spring in your step the whole day.
So is that what still motivates you? I mean, it'd be kind of like, how did you get into this? Like, what sort of was the architecture for you to sort of say, this is the area that you see as maybe the best way to contribute to space and development?
Mostly by accident, and I guess to some degree stimulation. It's a very niche interest, when you're growing up. But that's one wonderful thing about the internet, is it lets you meet all the folks who have your strange hobbies. When I left college, I was in grad school at Kent State, and I left to go to join the military during Operation Iraqi Freedom. Mm-hmm. And when I got back from the war, I just didn't feel like staying in the military for another term. I did 2, or going back to academia. So I got involved in local governments, and I missed actually ever getting to do any science or geeky stuff. And so I started hanging out on social media, and often ended up talking to a lot of authors in science fiction. And I decided one day just to go ahead and do a quick little video as a practice for something completely unrelated, and picked as a topic megastructures, gigantic potentials, cylinders, things like the O'Neill cylinder, habitats that people might live in the future, that sort of thing. And the O'Neill cylinder being very close to the heart for the NSS. And I put that out on the web, and people watched it. Like, I saw 10 of them watch it. I was like, wow, see, now I don't have to explain anymore. And then I got 100, and I got this weird email from YouTube saying, you have a subscriber. I said, what's a subscriber? So I ended up doing another one down the road, and that's just kind of where that took off. I think the second video, third video, and fourth video were on the Fermi paradox. Mm-hmm. And that's the big question of if space is so huge and so ancient, where is all the alien life? Where are those great civilizations we'd expect to see out there? And that's been one of our longest on-running themes on the show, is the Fermi paradox. That was our episode this Thursday, looking at solar flares and solar volatility. And along with space colonization, that's probably been our 2 biggest topics. And then artificial intelligence, the role of humanity in the future, and things like that. We just try to look at anything futuristic and see where it's going.
So I must say, like, I got into, I'm a higher education executive who has taught for many years and been very much part of sort of the transformation of the research and development arena. And what I started to see was so much growth and development and investment in space, but how few people in the public and how few students actually really knew what was going on above them and about them, and the huge implications it had for us on Earth. And so when I looked at your videos and your channels, I started to realize just how, again, your contribution is sort of bringing to the forefront the general population's ability to see how much this universe actually affects them and how exciting it is and how much we need to, in a way, shift our thinking from just looking at the world in an island or in isolation, but as part of this huge galaxy of billions of celestial objects. And so maybe just elaborate a little bit about how important you see your contributions, sort of the education of that next generation of citizens who are going to govern in a space world.
Well, I'd say in a very small way, we try to do what Carl Sagan did, or even what Mr. Wizard did, for previous generations. And there's quite a lot of giants there to be on the shoulders of there, like Sagan, just trying to make sure everyone is knowing what is going on with science and space these days. What can we do to advance that cause, and what is that future going to look like, or what could that future look like? Because a lot of times the hardest thing about paying attention to the future or thinking about the future is staying upbeat about it and realizing there is potentially a very good future ahead. And it's sometimes hard to overcome the apathy folks will have towards space if they're not already enthusiastic about it. This is not a stranger thing for the National Space Society. They're quite used to having to try to work with people and keep that enthusiasm up for decade after decade. We had the big boom after Apollo in the 70s and early 80s, but then not too much happened. And without folks like the National Space Society, we probably wouldn't have been able to keep that enthusiasm up to get to the International Space Station, let alone the SpaceX days, where it looks like we might finally be having that presence in space that we've all dreamed about and grew up watching in science fiction. And so in a small way, I try to make sure that everyone sees some of these options for the future and knows that there are some good options if we're up to these challenges.
Yeah, and I think that's very much what the Pioneer Award is about at the National Space Society, is to also, I think when you get that award, you see the other community that you've joined, and it's a pretty laudable community of people to be part of the National Space Society's award. But also what it does is, I think, as you say, the National Space Society has had a really central role over the years to keep space alive in the public domain and also within the government's domain, so that we continue to invest in our future, knowing that space really is very much our next frontier, and how we interact with it. And as you say, look at it from a positive lens. I really liked how you kept it in perspective, that this is exciting. This is where we want to go, and we need to invest, and we all need to be engaged and see it as part of our growth and development. And I think that's really at the heart of the Pioneer Award. It's very much being at the forefront of that frontier, but then seeing it move into the mainstream of today's science, but also art and culture and our life. We live a spacefaring world in many respects today on Earth.
Mm-hmm. Oh, yeah. There are, again, many of the people who received the award or won the awards in the other categories or sit on the board of governors or personal heroes of mine growing up, one of which is the Senator John Glenn from Ohio, my own home area, and I believe you were teaching here for some years. And, he's been quite an inspiration to us all. Plus, he was one of the people who, once he got back from space, continued to fight for space for his entire tenure in the U.S. Senate. And that is very important to keep not just that enthusiasm of the people up, because they're who the government looks to and says, hey, should we be funding this? What should we be doing with this? But also to keep that very active roll up with not just educators, but people in government, because they usually are very enthusiastic about technological development, but you have to be able to talk to them and show them what, where is the inspiration here for the public? Where can we do this to help out our state, our country, our world? And, there are so many influential people in government who actually have been awarded this or parallel awards from the NSS. And, it is very easy to forget how important it actually is to keep fighting for that day to day to day to day, not just in educating people, but, fighting for the funding, fighting for the engineering, and getting people who want to be enthusiastically in these fields to make a career out of them. And I'm very glad to get to play a little role in that.
Yeah, well, I think your role is actually pretty big. Now, maybe just in terms of a little bit of data, do you know who's listening and watching your show around the world? Do you have any kind of information to kind of get a sense of?
Sure. The single biggest chunk of our audience is the United States at about 40%. It varies from time to time. But after that, English-speaking countries make up about another fifth of it in Canada and England and Australia. And then about another third is Europe, and then spread out the rest of the world. A lot of impact into Eastern Europe. It's actually one of our biggest audiences in the old Iron Curtain states. And that is such a developing community for science and science fiction these days. That's actually kind of proud to get to know some of the folks who have been, getting up in those areas, writing more fiction. In an area that sadly has been underrepresented in that genre, with the exception of folks like Stanislaw Lem. There was just such a building science fiction, and I hate to say geeky community there, that is always the base, foundation for where we start getting our next generation of STEM researchers in the sciences and medicine.
Yeah, fabulous. Just fabulous. So maybe we should end on you just saying, what does this award mean to you going forward?
It's probably a reminder to redouble efforts. It's a great award for the folks who have helped out on our team too, to be taken, and given this award by such a prestigious group, and to, get an award that, again, so many of our heroes, at least, for those of us who kind of grew up in this community in the 80s and the 90s, moving towards space. I put it up one more time. I just want to thank everybody for that, because at the end of the day, it's anytime you get an award, it's a reminder not just to say, oh, look, you accomplished something good, but a reminder to kind of redouble your efforts going forward, and to make sure you're doing more work towards just getting more people inspired to move on to it for the future.
Well, I couldn't agree with you more. And I think and I hope that by giving you this award not only inspires you, but also continues to raise your profile and get that global community watching your shows, because they really are fantastic. And congratulations, Isaac, and your team from all over the world for an incredibly inspiring and fantastic channel that we're all benefiting from. And certainly, I think the future of humanity, in some ways, maybe in the small ways, in a better place because of the science and the knowledge and the creativity that you've brought to our world through the YouTube channel you've created. So congratulations again on behalf of the National Space Society, and we look forward to seeing all that you'll accomplish in the next phase following receiving this award. Thank you.
Thank you.
Hi, my name is Al Ansaldua. I'm an active member of the National Space Society and have been a space activist for over 30 years now. I'm about to tell you about a remarkable happening. You're about to see a video, and I'd like to give you a frame for it and introduce you a little bit to a lady named Professor Aida Wolfert, who carried out a 3-stage robotics contest in Mexico, and it all started in 2018. I had no idea when I gave this talk, and I think there's a lesson there. I gave a talk to some astronomy students in 2018, the summer 2018, in the northern campus of UNAM, which is the National Autonomous University of Mexico. The first talk was about orbital debris, one of my favorite subjects, and the second talk was about lava tubes on the moon and Mars. Well, that second talk sort of caught fire, and afterwards 10 students approached me with their professors and asked me what can they do in conjunction, in coordination with the National Space Society, to get involved with space and lava tubes and that sort of thing. They were very excited about the moon in particular. Well, over the next few days, I discussed with them, and there were other very soon, other National Space Society people like the late David Dunlop, and Lynn Zielinski, and also David Chevron. Early on, we discussed with the students and the Mexicans, what could we do? And a plan evolved that there would be a 3-stage rover robotics competition. It became massive very quickly. I had no idea. It was very surprising. It started in the summer of 2018, the planning, biweekly meetings. Little by little, there were stages that evolved. In 2019, in June 2019, in Monterrey, Mexico, there was an orientation, and then 2 stages. Later in 2019, in Puebla City, Mexico, there was a design competition, and finally, there was the contest later in 2019. What was remarkable about this is that there were over 300 students involved, 57 teams. Of course, we had to winnow those students and teams down, and that's exactly what we did through the design and so forth. And finally, we ended up with just 14 teams. Well, I don't want to steal the thunder from Professor Aida, but I just wanted to say that this was a very surprising event. It started off very low key, and it just goes to show there are some lessons here for us, I think. Number one, we really don't know. We do, as NSS members, we do a lot of space activism, and we really can't predict what is forthcoming from that activism. At least I can't. The other thing I noticed, or that I learned from this, was that there is a great yearning to get out into space and to get involved in space out there. I had no idea we were going to end up with over 300 students in Mexico, and this would last almost 2 years. It was a huge surprise and a huge lesson for me. There is a great yearning, especially among young students. So let's keep at it.
Hi, my name is Aida Wofford. I'm a professor of astrophysics at the largest public university in Mexico, the Autonomous University of Mexico, UNAM. I work at the Northern Campus, which is located in Ensenada, Baja California. In 2018, Alan Saldua, who at the time was a very active member of the National Space Society, visited our campus, and he gave 2 talks to our summer undergraduate students. The first was on space debris, and the second was on lava tubes as shelters in space. So inspired by Al and the students, I put together a team to design and carry out the first lunar rover competition in Mexico. The contest is called Towards a Lunar Base, and it is aimed at undergraduate students in Mexico. I'm the manager of the contest, but I also help design the mission for the contest with the help from Rodrigo Romo from the Pacific International Space Center for Exploration Systems, PICES in Hawaii, Al Ansaldúa from NSS, and a group of professors and engineers from UNAM and other institutions in Mexico. For the contest, we also received help from the Mexican Space Agency, the Aerospace Cluster of Baja California, and the municipality of Ensenada, Baja California, where my campus is located. The mission was to build a rover capable of picking up and storing rocks of up to 1 kilogram. The rover also had to visit 4 different areas of terrain. One was sandy, the other one had a slope, 30 degrees with a crater at the top. The rocks were either on the surface or semi-buried or completely buried. And so the mission was to visit the 4 areas of the terrain, pick up as many rocks as possible in 15 minutes and come back. And then the rover was controlled from a room without a direct view to the rover. So the rovers had cameras, and the contestant had a map of the terrain, and some markings were available on the terrain. The contest was divided in 3 parts. During the first part, there were some motivational talks from guest speakers, such as David Chevron, former NASA engineer, Rodrigo Romo from PICES, and Alan Saldúa. And during this first part of the competition, we also gave a detailed explanation of what was expected from the participants to the contest. The second part of the competition was a competition of just the designs, just the rover designs. And this phase involved a presentation of the critical design and the project plan in front of a panel of experts. To the second stage of the competition participated 25 teams from all over Mexico. And the third and final part of the competition was the actual prototypes were competing on the lunar terrain. So we had 14 teams come to Ensenada for this from all over Mexico. Only one team was able to complete the mission. And the winning team from Universidad Autónoma de Baja California, Mexicali, was invited by NSS to attend ISDC 2020 as a prize. So they were supposed to attend in person and present their rover. Unfortunately, due to the pandemic, this was not possible in 2020, and it was not possible in 2021 either. So I'm hopeful that at least some of the members of the team will be able to present their rovers in ISDC 2022 in person. If we're able to secure funding and allocation for version 2 of the contest, we will be happy to continue with this experience. It was really great, and we learned a lot. Thank you very much.
Well, I hope you folks noticed that there was no direct line of sight with these rovers. Everything was done from a separate room, remotely through monitors. All the directions were given through telerobotically. So it was quite a feat. And I wonder if you also noticed, I hope you noticed, that some of the rocks were either buried or semi-buried. So each rover had to actually dig out some of those rocks and contain them and transport them to a deposit where everything would be weighed. And the winning rover did exactly that, did it much better than the others, and deservedly won. So I hope you enjoyed it. It was fun for me to see and exciting. The students were all around. And I think this is just a portent for the future. We can do a lot more of this in various countries, including the United States. These folks, by the way, the winners of these this contest will be at ISDC 2022 and show off their rover. Thanks.
Dear Earth, we're sorry for all the things we've done to you. We're sorry for coal plants, oil spills, nuclear waste, dirty factories, auto emissions, wildfires, and climate change. We really didn't understand. We didn't mean to hurt you, but our needs got the best of us. Now we know there's a better way, one that will give us everything we need without harming you ever again. Can we start over? We have a new plan, and we really mean it this time. We promise. It's all about electricity. We know, we've tried that before. Coal, oil, gas. Those were the choices for a different time. But we promise to do better because we have a new source of power at our fingertips. Space solar power. The sun provides clean and virtually limitless power 24 hours a day. It is a huge, inexhaustible source of energy that will be kind to you, Mother Earth. The ways we currently harness solar power are a great start, but only provide energy for part of the day and are limited by weather and other conditions here on Earth. And your atmosphere, while we cherish it, reflects about a third of the sun's energy back into space. Solar power generated in space and sent back to Earth frees us from these limitations and will allow us to provide virtually unlimited amounts of energy to the entire planet, night and day. Space solar power is clean, abundant, and the costs of collecting and transmitting it back to you, dear Earth, are negligible. And space solar power is virtually emissions-free and kind to you. We have the rockets and the proven technology we need to start building space solar power now. We may even be able to utilize the resources of your neighbor, the Moon, to build these orbiting power stations. We really want to do the right thing, Mother Earth. We're ready if you are. Space solar power will help us to repair the climate and make you healthier than ever. So what do you say, Earth? Ready to give us a second chance? Space solar power is the answer. To learn more and donate, go to go.nss.org/SSP.
I've been asked if I could give a little walk-around tour of some of the space artifacts we have here at Future Ventures. I'll start with, at my desk, I keep a Martian meteorite, so it's always nice to have a little bit of Mars at your fingertips, as well as, all these meteorites. This one's from the Moon, the oldest volcanic rock ever discovered in our solar system, a recent discovery, pieces of Vesta, and some other interesting meteorites. But let's go walk around and look at some of, look at some of the bigger artifacts out in the main area. Oh, actually, before we do, I got to show you this. I haven't planned this tour, but I gathered all these Apollo astronaut signatures when SpaceX had its first successful berthing to the ISS, and I got congratulatory words for all of them. The larger version of this, because I had 2 copies, all handwritten, is sitting in SpaceX headquarters today to inspire the team. That was the reason I did it. I specifically wanted to get Gene Cernan to say some nice things, and I did. That was my goal. Soyuz flight deck, some other amazing stuff, like that headset was used in the first lunar module, rover ride on Apollo 15, docking hatch. So those are kind of cool. Then you have an entire Apollo couch, and I put the joysticks on it. This is where Neil Armstrong sat, and he had his hand on this device during launch. And if he did that, it would be an abort, which is kind of cool. Then you have a complete RL-10, which is amazing, right? Proving that regenerative cooling and liquid fuels makes sense. That's what got Wernher von Braun excited about that for Apollo. This is the only handle from any Apollo spacecraft flown. This one's from Apollo 11. All the others were destroyed as radioactive waste because these glow-in-the-dark tabs contain promethium-147. So every other handle that you'll see in a museum is a fake replacement. This is the only real one that flew on Apollo 11, a glove worn by Buzz on the moon. A couple of fun things here. We have Bernie Sanders sitting there like the boss in a Mercury suit, of course, long before that. And then this is my personal favorite, flown DM2 hatch. Is, in other words, the first thing to blow when the parachutes come out, and has these incredible solid titanium springs behind it that pushed it out. And that's the first thing that got jettisoned when the first two humans to fly with SpaceX went to space. Back here, I'll just show you one interesting thing: a complete lunar module guidance computer. So this is the whole thing, the IMU, all the computer boards, and I have it tucked in the corner here because it's actually mildly radioactive. It has thoriated magnesium in it, and I just discovered that this week. But it is also kind of special in that it is from LM2, meaning this is the one that was removed from the lunar module that's sitting in the Smithsonian, and it was used for some subsequent testing at an Air Force base. Here's a spare Skylab exercise bike, and what I love about this, I'll zoom in to the controls, is that of course you'd use a lunar module, switches and buttons, but of course it's heart rate and the usual stuff that you'd have on an exercise bike that's on there. So that's kind of wild. So let's go. Let me take a look at some other. Well, this is some amazing stuff in here behind glass on purpose. My favorite artifact, the cuff checklist that was on John Young's wrist when he did that famous 3-foot jump salute. Literally there on his wrist is this particular artifact, the eyepiece that was used in the lunar module of Apollo 13 on the AOT for getting back and doing the star sighting. Soon, there'll be, in the next couple of weeks, will come out a detailed analysis showing this was actually the first Hasselblad ever flown in space, personal possession of Wally Schirra. The reason that's somewhat controversial is someone else paid a lot of money for something claiming to be that. The radio that sunk to the bottom of the ocean with, the first, when Gus Grissom's hatch blew and it sank, but it's been recovered. Pretty archaic looking thing. This is part of the lunar module of Apollo 17, the armrest that was used for vertical takeoff and landing of the lunar module. In fact, I own a piece of every lunar module that's been on the moon. So a registered piece of the spacecraft, because in every single mission, lunar module pilot or commander brought back souvenirs, contrary to protocol, snuck them through the hatch, and have kept them all these years. Unbelievably, a flown Planet Lab satellite. Now, flown in quote marks because that's how far it got. It was an Antares launch that blew up at night, which is the best time to blow up for photography. And it landed on the beach unharmed and tweeted, yo, because the antenna, basically when the solar panels saw sun, it tweeted its existence. Lunar module descent engine, X-15 engine, lunar traverse gravimeter, fuel cell 1 and 3 that were literally used to test all of the lunar module, the command module electronics during development. And then maybe I'll end with something really cool over here. Actually, no, there's a couple more things I want to show you. Actually, a couple of really amazing things I want to show you. This is the actual, hand-painted Wally Schirra Cygnus 7 from Mercury, logoed, part of the spacecraft, which is kind of amazing. Mirror hatch, mission control, console. This is pretty amazing. It's the only biological instrument from the Viking program still on Earth. There's 2 on Mars, of course. Then in 1976, did a variety of experiments. 3 of those experiments were in here to try to see whether life existed on Mars. And, they dropped the soil into that flower petal. This auger, sort of stirred it up, and it went to labeled release, the gas exchange, and the pyrolytic release experiment here. And then in this, I have the actual GCMS as well. So I currently have it covered, but that was amazing. And Luna 9 Petal, that was, the first lander on the moon that sent back a panoramic image that was first published in a British tabloid. This is kind of a fun room. I call it the lunar orbiter room, in that solar panel, which is gorgeous, is a spare of the lunar orbiter, which, this model reminds you what it looked like. So this is one of those solar panels. And up on the ceiling, I have spares of, where is it? That's gonna be hard to see. The high gain antenna, some images that it brought back, the low gain antenna as well. And that's amazing that there was an analog film development lab, and then, raster scan and beaming the data back to Earth. A GINA engine, I've never seen one of those before, but, this is kind of a fun one. A spare observation system from a Salyut militarized space station, the one that fired a machine gun in space, where someone would be looking through these eyepieces to take photos of US military bases. As the satellite passed over, the film was developed up in the Salyut, dropped over Russia, and captured by plane before it hit land. So that is my rapid fire tour. There's more to see. Actually flown sextant from AS202. Oh gosh, I keep going on. Braun air handling system, which you could compare to the shuttle. Excuse me, not to the shuttle, to Apollo's environmental control unit. The entire environmental control unit. That you put the lithium hydroxide canisters in, and such. And then my first artifact, maybe we'll just end with that. The crewman's optical alignment sight from the Apollo 16 lunar module. That was the first item I collected. And that's what made me, my eyes were like, you can actually own something that's been on the moon for 3 days? Legally? Wow, how does that work? And then all this followed. So maybe I'll end it with that. That was the, breathtaking, for me at least, brief tour of the space artifacts here at Future Ventures. Thank you.
Space exploration is one of the most difficult science and engineering challenges that humanity has in front of it. In order to achieve this grand challenge, in order to even come close to meeting it, we need the talents, experiences, and cultures of people from all over the world.
There are now starting to be a lot of careers for young people who are going into college or graduate school.
If space tourism takes hold, it's the hotel industry, but in a unique environment.
There is a great need for young people coming into these fields because that has not been happening actually for a couple decades now.
Space exploration is more viable today than at any time in history, and the private sector is showing us how to get into space.
SpaceX has really shaken up the industry in the past 2-3 years or so, and by bringing this intense competitive edge that they have.
We need more scientists. We need more people who see science as an inherently vital part of our success as a species on this earth, of our ability to overcome any challenge that nature, that the universe might throw at us.
I would encourage all young people who are interested in being part of this renaissance in space exploration to follow their hearts. There are all kinds of jobs that are going to be available in aerospace in the coming years, in the near future.
Follow your passion, and then there'll always be an opportunity to tailor whatever you're interested in. You'll find a way to adapt that to an interest in space.
It's much more likely these days that if you have a specialty in biology or pharmacology, you could become an astronaut payload specialist or a mission specialist, actually fly on the space station, or fly with a commercial company to develop new stem cells or new protein crystals that could cure cancer.
Follow your dreams, dream big. Don't worry about what people think about your dreams or what they say, because if you are passionate about it and you are committed to them, you can make big things happen.
Hello, my name is Dale Scran. I'm the Chief Operating Officer of the National Space Society and also the Senior Vice President. I'm here to give an award, a very important award, the Chris Pancras Award for Space Activist of the Year. But first, let me tell you a little bit about who Chris Pancras was. Back before the pandemic, when we had an office, and a number of years ago, there was a person who did a tremendous amount of volunteer work for the National Space Society. His name was Chris Pancras. And this individual, he worked very hard. He worked long hours. And after a while, people noticed that he seemed like he wasn't looking so good. And it turned out that he was dying of cancer. He had terminal cancer. And they said it was expected that he would, quit, do something, whatever. But he didn't. He decided to spend the last months of his life working as a volunteer for the National Space Society. He worked at the National Space Society headquarters until his untimely death. And we decided to memorialize Chris Pancras to remember his dedication to the National Space Society, to create the Chris Pancras Space Activist of the Year Award. And let me tell you a little bit about this award, which I'm holding right here. It's a pewter carving or sculpture of the moon, something we think a lot about at the National Space Society, something that's really important right now as we go back to the moon with the Artemis program. And there's a base with a plaque that has the name of the winner and so on it. And now I would like to tell you a little bit about the person who is getting the award this year. And that person, without further ado, is Bert Dicht. Bert is focused on bringing value to the membership experience. As a part of this effort, he's initiated a really valuable program of new member surveys that I personally have found extremely beneficial. Additionally, Bert has done a fantastic job leading the National Space Society response to the COVID environment. He has led and hosted the National Space Society Space Forum program, where NSS members have had the opportunity to attend biweekly free online video sessions with famous space experts, NSS leaders, and more. This program has been an enormous success. Bert did this while leading the membership team as the Vice President of Membership. He is pushing forward our effort to reach out and activate life members. He is managing a process of bringing NSS dues in line with inflation. He is driving our effort to completely refresh our renewal process. For all these reasons and more, I am awarding Bert Dicht the NSS Space Activist of the Year Award. Bert, here is the award.
Oh, wow. Thank you so much, Dale. I'll show it to everybody so they can see it, and then I'll just put it down. So thank you so much, Dale. I am incredibly honored to receive this award. I've been involved with NSS for many years now, and I've been to the ISDCs where these awards have been presented, and I've been in awe of the volunteers who've received them. And to be in that company is just very humbling. I am dedicated and committed to our vision to create a spacefaring civilization, and it's just an honor to work with all of the great volunteers within NSS, with the membership committee, to try to make that happen. And I know we're doing a lot of this for the members themselves who help propel what NSS does. So to receive this honor, as I said, it's very humbling. I will continue to work and strive and work with our volunteers to make other things happen so we can propel and advance our vision. So on behalf of myself, again, I want to thank you and thank the awards committee for this great, great honor.
Bert, it's been a pleasure working with you, both as CEC and COO. You've been doing a great job. I look forward to a great rest of 2021. So as a previous recipient myself of the Chris Pancras Space Activist of the Year Award in 2016, I congratulate you, and I really thank you ever so much.
Thank you so much, Dale. Same here. I look forward to a very fun and productive rest of 2021, and looking forward to all the great things that are going to be happening in space.
Good day, everybody. My name is Lorna Jean Edmonds, and I'm here with my colleague Frances, who's going to introduce herself in just a minute. We're here to present to you, who I know are from all around the world, about the idea of universalization and the imperative to prepare our next generation of leaders to work in what we would describe as our new reality. But we're hoping that today we're going to capture your imagination, both in terms of the new construct that we think you're in, but also about the power of using debates and a new style of debates to really engage students in a way that we think they need to be thinking and collaborating in order to lead our future and be able to ensure our sustainability for the long term. But before I get started, I want to just give a chance for Frances to introduce herself, and then we'll come back to me and I will speak a little bit more as we talk further about this exciting idea.
Thank you, LJ. I am the Deputy Education Director of the National Space Society, and under my area comes all kinds of educational programs. And one exciting program we have, the National Space Society has been supporting for 4 years, is the SPUN Debate Program. The SPUN Debate Program started in 2017 at the International Space Development Conference in St. Louis, when LJ was presenting the very topic we're going to be talking about here. And there were about 250 students in the audience and another 150 adults. After her presentation, I noticed little pods of students that were very excitedly talking about what she had presented. And so I asked that I might join a group, and they graciously accepted. And during that time, we started to talk about the differences in cultures, political areas, religious opportunities that affect one another, and how we cope with those. How do we work through those? And how do we allow everyone to come to the table to help in decision making? Through that process, we thought about, wouldn't it be interesting if we started a debate program in which we talked about real space policy issues, but we brought in universalization, and we brought it in such that our arguments showed universalization concepts, as well as how we conducted our debates and even worked together. And that's exactly what we have done. This year, we had a debate June 12th weekend and also the weekend of June 19th. We had 10 teams debating. Each team had 4 students on it who had never met personally, had met virtually, and worked very hard together for the last 7 months. We started out with them taking an online course if they were new to debating or if they were a veteran debater, because we wanted them to start at the same area. We wanted to bring everybody to the table. No one was at a disadvantage. And that's exactly what we did. So we had 8 different countries involved with 8 different time zones, if you could imagine. And it was a fantastic operation to see it happen. And the outcome was really, really excellent.
So maybe I'll just kind of segue in and say, you're probably wondering, like, what is this universalization? And in really simple terms, what we're trying to suggest is that we're in a new frontier. We're in a new phase of our society. And it's not about globalization anymore. It's about our world within the universe. And unlike any other frontier, it's about all of us. And what we're trying to say is that you can't develop space policy
or you can't have Elon Musk and a few countries and billions of dollars investment in outer space happen without considering what's happening back on Earth. And that's the construct of the whole idea of universalization, is that we need to shift our thinking from a world thinking or a planetary thinking to saying, wow, we're part of this universe. This is big picture stuff. And what about our safety and our security and our sustainability when our lens is about being out in space and looking back and asking the question, do those who control the universe or outer space, like our near space, control us? And if so, who is going to govern us? Is it the few countries that are the powerful? Is it the few space barons like Elon Musk and others who've got the large amount of resources to be able to control what is invested in space? Or is this something that we want to engage all of you about? And what Francis and I realized, we're the co-founders of this fun debate, which is called Space Policy and Universalization, is that we need to engage young adults. We need to get them thinking about space in a universal construct, not as some separate country or frontier, but that we're part of one whole. And so what I want to do now is I just want to transition and show the video so that you can see the students in action and the experiences of the last couple of years as these students started to learn and understand about space, universalization, and their role as the next generation of leaders. So I'm just going to sit back and let's enjoy the sizzle that we've prepared, and then we'll come back and talk a little bit more about the debates and universalization.
Well, this debate opportunity has taken that bold step of bringing it into the domain of young adults. If what we've done is created that energy and that interest. When you see these students speaking about it and using the terms that we use as if it was always their term, I don't think there's anything more rewarding, quite honestly.
Universalization is the act of all the nations on Earth, all the people coming together to tackle problems that affect us all.
Universalization, in my point of view, will change the world to a better place and a whole new league of problem solving together.
Figuring out a plan for universalization space is something that's really important and is really impacting us right now.
We want every individual involved in every matter because we're humans and this is our world. We need to rule it together.
We want all countries to be able to have that international collaboration that's going to bring us all together for a common cause.
Find a way to agree on new laws in space that are helpful and that everyone can cooperate and agree on.
I think it starts now and we begin that conversation, and as we plan, we are making way for generations to come to go to space in peace and borderless to boot.
You don't see that borders, you don't see that differences. Just like we have seen in the debate now, the students from different countries are actually part of a team.
The opportunity to put it in the hands of our next generation of leaders is what we need to do, because they're the ones who are going to help us really resolve, because it's their world. They need to own this.
Do you guys all want to live in space?
Yeah, sure.
It's my dream, actually.
It's like a magic. So we can discover all the things in space.
Space is a mystery. It's filled with adventures and I just want to touch the stars.
I think we can see the excitement that the space debates or the SPUN debates have created amongst our students. But let me just kind of bring this back to home again. This is real big stuff. I think you've got to take it in context that the whole idea of universalization has been reinforced by the fact that COVID this year, Black Lives Matter, and the reality of climate change and the garbage, not only on Earth, but the debris in space, has really reinforced that it's no longer an arena where we can just compete and innovate for the sake of innovation. We have to cooperate, and we have to learn how to do that. And the people like Elon Musk, what they do is they're creating an energy and an excitement, and we want to be excited about this new frontier because the possibilities are enormous for benefiting all of us back on Earth. But we also want to be sustainable, and we also want to take care. And I want to just put it back to Francis and maybe just kind of introduce the next topic this year and how it so relates to even Elon Musk's work about sending people into space and the idea of space tourism, but the fact that there's traffic management and there's debris and there's all kinds of consequences. And at the moment, there is no governance structure. And that's what the SPUN debates brings home to these students, is that how do we function in this new reality? Francis.
Yeah, our resolution topic this year is space traffic management should be regulated by the UN Security Council. And I have to say, when our groups first started preparing for this back in March, they all felt, of course, that's the answer. Of course, it is the answer. How can we come up with a negative argument for this? And now as they've delved farther into the issue, they see their pro and cons and lots of things to talk about. As a matter of fact, even in our real world, there's a lot of conversation on who owns what, who is responsible for what, who should be doing better with what. And all of those arguments have come up. And we talked about the perceptions that students have in their different countries and that their governments are suggesting. And is it truly what they feel, or their perspective of another country? Is that correct in what they've come up with? We also took a Harvard diversity inventory, which was very, very interesting and very important for us, because through that inventory, we were each able to choose topics and find out about biases that we didn't even know we had. And so those were other things we talked about when we start talking about whose responsibility is it to keep space clean and secure and able for others to pass through that area.
So fundamentally, what universalization does is it challenges these students to ask the question, are we going to colonize space in the same way that we colonize many other regions of the world? Or are we not going to be performative? We are going to be real, and we are going to be genuine, and we are going to work together for the benefit of all of us, for the sustainability of humanity, by being equitable, inclusive, cooperative, and responsible in terms of our development of innovation. It's no longer innovation for the sake of innovation, but everything we do, we have to ask the question, who at the end of the day is benefiting? And our hope through these SPUN debates and through talking about universalization and engaging people in these debates is people will start to see that space exploration and space policy cannot function in isolation of all of us from around the world, all being involved and having ownership and excitement about the possibilities of how working and functioning and living in space will benefit all of us. And that's really at the heart of the SPUN debates. And I think you saw in the excitement of the students is they, you see they're intelligent, they're excited, and they have hope. But what we feel when they go away, they feel this added responsibility to do it in a way that they are inclusive and cooperative, and they learn the skills. And so we're really excited about this year's question about space traffic management and the engagement of the commercial community, the NGO community, the academic community, and just citizens in general, looking at the possibilities for building our world within a universe in which we all get to play a part of. So thank you for the chance to share our ideas, and in particular, to profile our next generation of students experiencing how to work and lead in this next generation through the SPUN debates. Thank you.
The SPUN debates will be on NSS YouTube. They are being held during the tournament the weekend of June 13th and also June 19th. So we hope you take a look and see what the outcome was with these excellent, excellent students. Thank you.
Dear Earth, we're sorry for all the things we've done to you. We're sorry for coal plants, oil spills, nuclear waste, dirty factories, auto emissions, wildfires, and climate change. We really didn't understand. We didn't mean to hurt you, but our needs got the best of us. Now we know there's a better way, one that will give us everything we need without harming you ever again. Can we start over? We have a new plan, and we really mean it this time. We promise. It's all about electricity. We know, we've tried that before. Coal, oil, gas. Those were the choices for a different time. But we promise to do better because we have a new source of power at our fingertips. Space solar power. The sun provides clean and virtually limitless power 24 hours a day. It is a huge, inexhaustible source of energy that will be kind to you, Mother Earth. The ways we currently harness solar power are a great start, but only provide energy for part of the day and are limited by weather and other conditions here on Earth. And your atmosphere, while we cherish it, reflects about a third of the sun's energy back into space. Solar power generated in space and sent back to Earth frees us from these limitations and will allow us to provide virtually unlimited amounts of energy to the entire planet, night and day. Space solar power is clean, abundant, and the costs of collecting and transmitting it back to you, dear Earth, are negligible. And space solar power is virtually emissions-free and kind to you. We have the rockets and the proven technology we need to start building space solar power now. We may even be able to utilize the resources of your neighbor, the Moon, to build these orbiting power stations. We really want to do the right thing, Mother Earth. We're ready if you are. Space solar power will help us to repair the climate and make you healthier than ever. So what do you say, Earth? Ready to give us a second chance? Space solar power is the answer. To learn more and donate, go to go.nss.org/SSP.
My name is Dr. Andrew Wilson, and I am the Competition Manager of the International Space Solar Power Student Competition, which is a global undergraduate and graduate level annual event presented by Space Canada in partnership with the International Astronautical Federation Power Committee, National Space Society, and the Space Generation Advisory Council. The competition involves student team projects that addresses the sustainable and affordable space architecture and design of a space solar power concept as a form of renewable energy. Now in its fifth year, the focus of the 2021 edition is to address key challenges and new innovations in architectures of solar power satellites, with particular attention made to addressing life cycle CO2 challenges. We received a record-breaking number of entries this year, which has now been narrowed down to just 8 outstanding semi-finalist teams. Of these 8 teams, just 3 will be selected to advance to the finals at the 72nd International Astronautical Congress in Dubai, based on their initial project results presented as part of this conference. So it is with great pleasure that I present to you our semi-finalist teams. Please join me in wishing each team the best of luck, and I hope you enjoyed our presentations.
Hi, my name is Miles Turner, and I am joined today by Carson Corsi and Thomas Rodriguez to present to you all the SPS Builder concept. The SPS Builder concept came from the need to construct large structures in space that will be used for solar power satellites. The concept incorporates 4 key features. First, being the design can help construct and maintain a solar power satellite through the use of small satellites. Second, being the concept can use energy that is readily available in the environment, such as solar power energy or radio frequency energy from a pre-existing solar power satellite. Third, being the concept allows for satellites to assemble semi-autonomously/autonomously. And fourth, being that the satellites are versatile in their design, so they can offer several different functions for the operation of a solar power satellite. To achieve each of the 4 key features set out on the previous slide, we set out to design a first iteration of a satellite using available CubeSat designs as a foundation. What we produced was a small, simple satellite called a worker that is less than 200 kilograms with a size of 0.3 by 0.3 by 0.1 meters that uses 4 electromagnets for assembling and disassembling with other working satellites and can use interchangeable specialized systems commonly seen in solar power satellites, such as mirrors, solar panels, and radio frequency receivers and transmitters. In terms of the on-orbit autonomous assembly, the use of a free flyer approach is considered. The free flyer approach consists of each worker being its own independent spacecraft with its own propulsion system, power system, ACS system, data bus, communications, etc. These systems allow for each worker to have a specific degree of intelligence to allow for autonomous assembly. While the complexity of this system of satellites may be high, the advantage of the free-flyer approach allows for the workers to be sent up to space over time along rideshare opportunities to spread the cost of an SPS system.
Our worker satellites will be utilizing electromagnets to conduct several of its necessary operations, such as docking with a pre-existing solar-powered satellite without the need for added precision sensors and thrusters, as well as assembling and disassembling with other nearby workers in space by varying each worker's electromagnet's magnetic field. Additionally, by using electromagnets, the cost of a satellite can be brought down, since our electromagnets are inexpensive to manufacture and can be lightweight as well, as there is little chance of mechanical failure due to little to no mechanical parts being in an electromagnet. In addition to helping docking, electromagnets also allow for inductive coupling capabilities, which can help in transferring energy across the system. To gain an understanding as to how the workers could assemble and repel themselves in space at close proximity, a study was completed on the attraction force versus the distance of two electromagnets. The electromagnet studied was modeled as having an iron core, a copper winding, and a stainless steel housing, as can be seen here. In the plot shown, it can be seen that as the two electromagnets operate closer together, the attraction force becomes much stronger, as is expected. The same attraction force can also be assumed for the repulsion force, which leads to the conclusion that localized attraction and repulsion of workers to build a space structure could be achieved.
It can also be thought that by using electromagnetics in the workers, the transfer of energy from one worker to another is possible by using inductive coupling. This would be as simple as adding a circuit to allow for the generation of AC power from the DC power source of a worker, and then using the existing copper windings in the electromagnet to create a local fluctuating magnetic field that interacts with another worker's electromagnet to create a current. The transfer of wireless power then could lead to providing power to sections of a large array of workers that may need more energy. For time's sake, we'll review 4 of the key base systems of a worker satellite, with the first being the propulsion system. It was decided that each worker would have 4 cold gas thrusters at the core of each electromagnet, as outlined by the blue boxes, to help assist a worker maneuvering to its initial location for assembly and operation. Next, for the power system, it was decided that the 4 high energy density batteries outlined in green will connect to one of the 4 electromagnets to provide the electromagnet with enough energy for attracting and repelling itself to other workers. For the navigation system seen in the control stack outlined by the orange box, a real-time kinetic global navigation satellite system was chosen to allow for millimeter close proximity measurements between the workers so that a worker could know where it was in relation to other workers for assembly and disassembly. For the ADCS system, outlined by the yellow box, it was decided that a 3-axis attitude control system using reaction wheels would be used to allow for the worker to reorient itself when one of the electromagnets could not be used as a magnetic torque rod with Earth.
Here's a render of 3 specialized systems that can be used by a worker to help construct a solar-powered satellite system, with the first on top being a mirror array that would be used to help to redirect direct sunlight to a solar panel, the next one being a solar panel that can collect solar energy, and the third being a radio frequency receiver and transmitter that can be used to collect radio frequency energy or send radio frequency energy. Each specialized system would be able to attach the top and bottom of a worker satellite to allow for a variety of use cases, such as the use case of a worker collecting solar energy from a solar panel and then sending this collected energy to Earth using an RF transmitter also connected to the worker. This is what you see on the right side here. Ideally, by assembling a cluster of workers together with a variety of use cases, you essentially will be able to create a modular, independent, very robust solar-powered satellite system. Here you can see our concept of operations. This first portion on the left is showing a stack of workers being sent up to space, assembling autonomously, and then deploying their specialized systems and conjoining with other specialized systems and satellites. In this middle portion, you have the addition of more workers being launched into space and assembled, and then going on to complete their specialized tasks and assembling with each other. And then this third section shows as individual satellites break down, new satellites can be deployed using rideshare opportunities and can go and modularly join the system. Here you can see a render of what a stack of workers would look like in a flight-ready position. You can see that the specialized systems are not deployed and the workers are assembled as a stack.
help to address the number of workers required to make an operational solar power satellite, the worker concept is planned to be scalable, with each worker being less than 500 kilograms and 1.5 by 1.5 by 0.5 meters in size. This would mean that approximately 444 satellites would be needed to make a 1 by 1 kilometer sheet of workers, which is the typical size of more modern solar power satellite concepts. Moving forward, to help test the feasibility of the SPS builder concept, research is needed in testing of assembly and disassembly of spacecraft in space using electromagnets, the transferring of energy in space wirelessly using electromagnets, the interacting forces that occur between the spacecraft's electromagnetic and the Earth's electromagnetic field, and the potential added controls on electromagnetic spacecraft with other local electromagnetic spacecraft.
The University of Maryland would like to present its submission for the 2021 International Space Solar Power Student Competition, Automated Health Check for Space Power Satellite Systems. But first, what is space solar power, and why is it needed today? It's no secret that we're facing a global climate crisis, primarily caused by our reliance on carbon-emitting energy sources. In order to fight it, we need to turn to innovative new sustainable energy sources, and in that search, humanity needs to leave no stone unturned. The concept of space solar power was first introduced in the 1970s as a way to address climate change and has been studied ever since. Satellites composed of large arrays of photovoltaic panels set in orbit around the Earth will collect energy from the Sun and then beam that energy back to Earth via a laser beam or as RF power. Deploying solar panels in space has many advantages, including no space constraints, no losses due to the atmosphere or weather events, and the ability to beam clean, renewable power from the sun 24 hours a day. There are also many challenges associated with space solar power. Namely, these systems would be very expensive to implement, are untested, and may be costly to repair. Another factor we must consider is the CO2 released in the process of manufacturing, transporting, deploying, and repairing these systems. Because the CO2 cost is so high, it is essential that we maximize efficiency over the entire lifespan of the system. Our innovation is targeted at doing just that. An automated health check system is hard to generalize for all SPS, so we will stick to SPS Alpha Mark II when describing our system. The two main parts that we want to track are the health of the reflectors and the health of the photovoltaics. But first, let's define what we mean by health. Here is a diagram of how a typical SPS system is designed. A reflector is in good health if it reflects as much light as possible towards the solar cell. An example of an event that would lower its health is a micrometeoroid impact. A hole through the surface of a reflector could cause a slightly lower reflectance level, as that particular area where the hole was made is now not able to reflect light. If a small hole is made, it might not make sense to replace the entire reflector or repair it at all. On the other hand, if a large rock came through and made a big hole in the reflector, we might want to replace it because it is taking up space that could be used for a fully functional reflector. Now onto photovoltaics. A photovoltaic is in good health if it is able to convert the reflected sunlight as efficiently as possible. A micrometeoroid impacting a photovoltaic might be more damaging to the overall functionality of the system because you lose the ability to convert concentrated light at that point, whereas an equally sized damage area in a reflector loses only that amount of area of unconcentrated light. This means that we should value health checking for equal areas of photovoltaics more than reflectors. Now, how do you actually determine the health of each of these components? Again, we will begin with the reflectors. Here is a rendering of one of the reflectors on the SPS Alpha system. Using a LiDAR-like system, we can determine if at any given point a reflection is detected. We can create a daily polar coordinate map of the intensity of a bounced laser at any given point on the reflector. For a working reflector, we expect most of the light to not return, but for a dysfunctional reflector, the light could reflect back. This would indicate that the reflector is not oriented at the photovoltaics properly at that point on the reflector. At the center of each of the reflectors lies a solar cell configuration needed to power the LiDAR unit. Within the center of each of these reflectors could also contain a computer necessary to store and process the data provided by the LiDAR unit in the middle. An added benefit of using solar panels on each reflector is to ensure no single point of failure for all detectors, such as a centralized power source. Each day's data will be stored within each reflector and compared to the previous day. Only if a deviation from normal is detected should a given reflector send a wireless signal to a control module to beam a message to Earth that a hole was detected. The damage can be confirmed using a pan, tilt, and zoom camera positioned on the backbone of SPS Alpha. To track the health of the photovoltaics, we can simply track the energy generated by the panel at any given time and compare it to the day before at the same time to match the expected orbit. At the same time also, we can take a snapshot of the entire photovoltaic array. This could be done once an hour. This way we can keep a log of what each of the photovoltaic cells looked like at any given time in orbit for reference. Then, if we detect an anomaly, which is defined as an unexpected loss of energy relative to the previous day at the corresponding time, or a drop relative to their photovoltaic cell neighbors for a given time, then we can do a pixel-wise comparison of the day before and the current image. If a significant difference is discovered, it is reported to Earth, along with a picture of the potentially damaged photovoltaic. To limit the launch weight and CO2 impact of replacement missions, maintenance will be performed robotically. The existing design for the SPS Alpha already includes modular push-pull robotic arms, which may be adapted for reflector maintenance purposes. This proposed SPS automatic health check system will maximize SPS station efficiency over its entire lifetime. The technology we propose here is an essential part of any SSP to maximize its efficiency. In the end, it is only a small piece of a large system, but that system will one day change how we gather energy. Thank you for listening.
Hello, we are the student for the exploration and development of space at Indiana University, Purdue University, Indianapolis, in the United States of America. Our project proposal is targeting the development of an industrial and lunar-based solar power satellite manufacturing facility. Why did we choose the moon? Well, the moon has an abundant amount of resources that can be useful to produce solar power satellites components. It is also the closest natural satellite to Earth. But also it allows us to go further beyond the Earth orbit to reach Mars and beyond other planets. Large-scale use of space-based solar power satellites opens up opportunity for more sustainable energy resources. But producing those components is costly. The economical impact of producing space solar power on Earth will cost billions of dollars. That's why we are shooting for the moon, to be able to create those components, harvest the silicons, the iron on the moon, and use those to manufacture the satellites that will be used later on to produce the mechanical components. Our proposal is focused on using thorium, which is found in abundance on the moon, as a source of nuclear energy, which will be transmuted into uranium-233 and will power the lunar factory that will produce the iron. Multiple components will be harvested on the moon, and we'll be dealing with qualitative and quantitative assessment of the production of iron, silicon, and essential components in the manufacturing of solar power satellites. With this project, we'll also incorporate ability to have micro nuclear reactors that can power the components of the solar power satellites once they are in orbit and in operation. We'll also investigate different aspects of wireless power transfer and energy transmission throughout the orbit of the moon and beyond. And some of the deliverables of our project will be explained by one of our teammates, Young.
Okay, Thank you, Eli. So one of the deliverables for our project proposals will include the graphics that I believe that in the past of the competition that most of the judges actually place a great value on the visual communication of our project, and definitely we actually include the structures of the manufacturing and how do we set up for the nuclear nuclear power plant using thorium. And another thing that we'd like to actually add on in our project proposal is the thermal management, which is one of the critical issues that we need to actually tackle when actually talking about our project proposal. And because a simple simulation for our project, we will try to actually provide that in the project proposal so that all the judges and the reviewers can actually have a simple kind of overview about what is going on and how all of this nuclear manufacturing can be operated safely on the lunar colony. And of course, we also will actually include some storylines and how do we actually, from starting from the moon, from the Earth itself, we set up the procedures, the logistics to actually set up all the manufacturings on the moon. And we will attach some of the simple video to actually explain all the logistics. And another important thing that we also like to consider is that the cost and the bill of materials. So that we know that for decades, the motivations for power from space has been to actually make it cheaper than the conventional energy and to be non-polluting. So we will include a rigorous accounting for all systems needed in the space and in the orbit with the estimates of the mass needed so that it will be converted into a US dollar. A bill of materials we will actually include in the project proposal so that to identify the key technologies so that the technology readiness level can be estimated. And of course, the lower technology readiness level will be higher risk, higher mass will be a higher cost, but the bottom line is that our story will be based on the power that is cheaper than wholesale electricity after N years. And next step, we will include an important part of the story, which is the concept of operation. So as we know that NASA have this thing called the architectures, and our team will follow a NASA example in creating our own so that it will be schematically depict the location and orbits in the space and the movement of materials and energy among them. So that we will actually include and explain that in detail so that we can catch any holes or gap in our approach. And lastly will be the risk and safety. So as we know that in our project proposal, we include the nuclear thorium, which will instantly actually raise the concern that will need to be addressed firmly and thoroughly. So, and we will include a risk assessment in part of this. And our team will actually assign each of one of the lead roles to our team members to actually anticipate any possible harms which can occur at any point for our ConOps. And from this, our team will try to mitigate and determine how to avoid all the errors and recover from all of them. That's all from for most our deliverables for our project proposal. And I pass back to Eli. Thank you.
Thank you very much for listening to us. We look forward to the rest of the competition.
Hello everyone, my name is Ricardo Pereira and this is our presentation towards the Space Canada contest. Our project is entitled Energy Mules, a novel solar power satellite system architecture capable of energy storage. We are a team from the University of Aveiro, namely the Institute of Telecommunications. We are located mainly in the central region of Portugal. In order to explain the wireless power transfer system that we will be studying, we will begin by presenting this schematic. Basically, what we want to do is to send power from point A to point B that will propagate a certain distance L. Now, we will study the wireless power transfer with a non-conventional method. This is called quasi-optics. This is basically a modified version of optics that takes into account the divergence of the electromagnetic radiation. The fundamentals of quasi-optics are that the radiation is approximated by a Gaussian beam. This beam can be transformed using focusing elements, and with that we will be able to optimize the beam shape in order to have the maximum wireless power transfer efficiency. In our case, this quasi-optical system will be composed by a DC to RF oscillator. This will power an antenna that will generate the Gaussian beam. This first Gaussian beam will be focused, and the second Gaussian beam will be able to transport power to our specified distance with maximum efficiency. The reception will be performed by a rectangle. And using this, we will be able to have a solar power system that is capable of generating power from the sun and transfer it down to lunar bases. Of course, we are not specified to the lunar case, but to any situation that has insufficient solar incidence. In the lunar case, we have 14 days of shadow, and so we will have a satellite constellation that will generate power when they have solar incidence and transfer that power to the lunar station when we are directly above it. In order to do that, we need to have into consideration the orbital parameters. We take as an example the Lunar Reconnaissance Orbiter that has a minimum altitude of 20 kilometers. And this will be the wireless power transfer distance that we consider for our system. Now, this the overview of our system. This is composed by the power generator that is composed by the luminescence solar concentrator. This will focus power, solar power into a solar cell. The energy will be stored in battery packs that will later be used for radiating power in antenna arrays.
This presentation will follow the energy flow, and in that sense, I will begin by presenting the power generation. In order to generate power, the orbit parameters described by Ricardo will be used to develop and implement a photovoltaic cell. In the next slide, we can see that these cells will follow the already successful hybrid terrestrial PVs, with optical active layers in luminescent solar concentrators and as downshifting layers. The addition of the solar concentrators increases the efficiency, which is our first original contribution. The fabrication of the luminescent materials will follow the experiences of the CISECU group. The material selected for this has the following features: high absorption coefficient, IQ values, the large ligand-induced Stokes shift, which prevents self-absorption, and high thermal stability. If you could change the slide. Within this process of power generation, a battery layer for storage of energy is especially important. During the sunlight exposure of the orbit, the battery will collect energy from the sun and when on top of the moon station transmit it. Although the battery is not an investigation theme in this project, it will have lithium-based cells due to having the highest specific energy and low manufacturing costs, which are commercially available. But what is important here is the development of electronic circuitry for efficiently coupling the DC power harvested from the solar cells to the battery, and the power from the battery to the DC to RF converters. Moreover, an overall battery supervision needs to be implemented to protect it from overheating, overcharging, control the state of charge and of health.
This battery pack will enable us to store energy, just like Elena said, and we will use this energy to power gallium nitride oscillators that we have already experience with, since we worked with this technology in in a project that involved half-sat satellites. These have shown to be a robust solution for high-power RF situations and will be used also in this project.
Now that we have an RF oscillation, we need to transmit it to the ground station. For that, we need some kind of antenna arrays that generate a Gaussian beam. These arrays of antennas can be constituted by patch antennas or horn antennas. Patch antennas gives us a more compact solution, but horn antennas gives us more direct beam. Also, we can use lenses to focus and shape the beam of transmission, so that in the ground station, about 20 kilometers from the satellite, we'll have a beam with a 10 meters radius. This gives us a more optimized power transmission. On the power reception part, on the ground station, we will have rack antennas that will transform RF waves onto DC power that will be stored in batteries to later be used. However, this part is not it's beyond our project.
And our team, this is our team, the team that built our this project. We hope you enjoyed our presentation and appreciate this opportunity. Thank you.
Thank you very much for listening to our proposal presentation for the International Space Solar Power Student Competition. I'll just give a quick introduction to myself. So my name is Shihan Fernando. I'm based in Brisbane. I'm a technology and space artificial intelligence subject matter expert. I'll pass it on to Darshan to give a bit of an introduction to himself as well.
So I'm Darshan, also based in Brisbane. My background is actually in robotics engineering and technology strategy as well, as it relates to emerging technologies and emerging innovations in our global world.
Excellent. All right. Well, we all know that the Earth and humanity and society is endeavoring upon what we call Space 2.0. It's a very exciting new space age. There's a lot of new ground that we are all looking to cover. And one of the biggest contributors to all our discoveries and all our progression in this area is to do with satellite data. So this satellite data, we are generating so much of it on a day-by-day basis. However, it does come at a cost. For this particular project, we are looking at space-based solar power, in particular solar-powered satellites. There are, whilst there are many benefits of solar-based power satellites, there are still some cost to the Earth in terms of carbon impacts and how that affects the environment, as well as the carbon impacts of that on the Earth. Darshan, would you like to perhaps talk a little bit about the concept of solar-powered satellites and how it can link into our proposal?
Sure can. So we've got the concept of a satellite, as you see floating around in space these days. We also have the concept of solar power, which is most traditionally seen on roofs of houses by many consumers across the world. But we kind of talk to the paradigm where you're kind of getting the best of both worlds. We lose a large percentage of the power that the sun produces when it comes through the Earth's atmosphere. Whereas if you were to have that ability to capture the sunlight outside of our atmosphere, you will capture a lot more. And so what we're thinking as that high level vision for the world as we go forward is, how can satellites capture that solar power in its raw form and almost beam it down to Earth? One, you're getting a lot more throughput in terms of how much solar power you're actually getting through. Two, you're actually making it a little bit more efficient because you're not having to build a whole bunch of different mechanisms to capture that. You're kind of channeling it through one or two or three, I guess channels itself. With that, as Sheen mentioned, there are some benefits that come off the back of getting that process up and running, but there's also some major benefits because you are making it a much more green world, less reliance on coal as an example. With these benefits, it's really about how do we capture that and minimize that as much as possible. And that kind of fits into our solution, which is really how do you track the process from start, as in the ideation, through to the launch of these satellites? And how can you make sure that when you're talking about decarbonization specifically, you're not creating more carbon in our atmosphere than we're actually reducing? So I'll pass over to Sheen, which will talk through the concept in detail.
So we propose to perform analysis such as object detection, trend management, movement analysis, and we can also partner with organizations such as Orbital Insight or Planet. So how we propose to do this is basically by using satellite data, which is ground pointed, we can actually look to track things like vehicles, supply vehicles, trucks, cars, logistics, freight, and we can understand how those suppliers feed into the creation of solar-powered satellites, and we can understand their suppliers and even their suppliers. So from a aerial photography perspective especially, we can look to really understand the full end-to-end supply chain and really understand through various geo data sets how we can figure out the cost of carbon from each of those supply chains into the environment. So there are some technologies that we can actually link our proposal to. One of them could be something like Bitcoin. Dash, would you care to explain a bit more about the Bitcoin linkage there?
Sure can. So you've got the concept of Bitcoin, which is underpinned by blockchain, which many of you may have heard of before. The reason we think it's the viable and probably the best solution for tracking this, I guess the carbon outputs, etc., across the supply chain, is because it proves that what goes into it cannot be pulled out. It's authentic. It's non-reputable. It's your source of truth when it comes to tracking the output, whether it be positive or negative, all the way through. Because of these concepts that you can't change what's been written, it really proves to be the one ideal one-stop shop for tracking for our purposes. And it's using the paradigm that some other industries are using at the moment for their own purposes, but shifting it to the space industry, specifically the satellite production industry, to make sure we capture the right information at the right time, which helps us with the right benefits and outputs at the end of the line.
Excellent. And once we look to build this model, and just to make it very crystal clear, it is a carbon satellite supply chain model. We are actually looking to discover if there are any linkages that we can perform with artificial intelligence and predictive analytics. So our model is a current state view of the carbon impact supply chain into the creation of solar powered satellites. But once we get this model up and running, we would really love to work with partners and build a model to actually understand how we can predict the future so that we can actually help mitigate future risks of the carbon impacts on the Earth. And this will, really help, future satellite, manufacturers, companies to actually understand and get more transparent in terms of how their suppliers and how their suppliers, what their carbon impact is to the creation of the satellites. And overall, we really feel that our proposal will really help reduce the carbon impact of SPSs on the world. And with this will create a better place for us to live in, as well as help progress space-based exploration. Thank you very much for your time, and looking forward to the other proposals as part of the competition this year.
Hello, my name is Soki Akutsu.
And Tatsuya Yamagami.
And Takahiro Onishi.
And I am Yusuke Kishida.
Today we will introduce our project overview. This theme is how to sell the microwave. Let's start and introduce. We are Tanaka laboratory members. Our laboratory is in ISAS and JAXA, and our main research subjects are study of WPT and high power generation and discharge phenomena. So our members is from several universities, and we have many backgrounds. So we are the educational volunteer of SPS for high school students.
First, we are studying to realize the commercial SPS. We think there are three big problems to be solved in order to realize it. First point is technical issues. Second point is breaking through not well known. Third point is social and business systems. Example of technical issues are structure, beam control of microwave, and discharge phenomena. In fact, our laboratory are studying to such issues, and these issues have been studied for a long time by many researchers. Second point is breaking through not well known. In previous research in JAXA, 2/3 of adults answered, "I don't know SPS at all." When rectangle is built, understanding its neighbor is necessary. So, we must raise awareness of publics to realize the SPS. Our team conducts public relation activities, opening to public and lessons for high school students, and online classes for children. Third point is social and business system. This point is the main topic of project. Social and business system means tasks other than engineering. For example, tasks are how to sell the microwave and the problem of frequency assignment, how to make big structure in geostationary Earth orbit. Main detailed discussion other than engineering aspect will be required, and these issues are not so focused yet. We are identifying the issues of realizing the commercial SPS. Our project goals are defining how to work on the issues. Our project will become a big step of the practical SPS. Next is details of tasks other than engineering. This page shows about how to sell the microwave. We need to discuss how SPS will be operated as commercial base. Vendors of the microwave will be able to operate SPS like oil tanker. So we can say they need not build the rectangles themselves. In our projects, we consider who should build rectangles from the perspective of selling the microwave and where is potential sites for the rectangles. Finally, if we can go finals, we will propose how to sell the microwave. This page shows the problem of frequency assignment. Frequency assignment is the big issue of realizing SPS. So, first approach is investigating the optimum frequency. It is included technical issues. We should consider several attenuation and antenna size. Next is investigation's current situation. We are investigating how the current situation of spectrum use is in the world and how we use in ISM band for commercial investigating the process of frequency assignment. We must know what the process of frequency acquisition is. And we are investigating how the current situation of WPT is in ITU by interviews of expert persons. Finally, we will promote frequency assignment for SPS. And next, this page shows how to locate big power station in GEO. In previous experience, we expect what will be occurred when big power station is located in GEO. For example, border declaration is 7 equatorial countries affirmed their sovereignty over the positions of geostationary orbit over their territory. We think international problem will be occurred when big power station is located in GEO, because SPS will be the biggest satellite and first power station in GEO. So we are analyzing previous experience such as Bogota Declaration and analogy of communication satellite treaty, territorial rights of Antarctic and the Moon. Finally, we will propose how to solve international problem of SPS.
We will introduce a project process. First step is identifying the issues, and we have done this. And next is interviews of related people. We interviewed several related people to identify the issues, so we can present by summarizing all of the opinions. And we have planned to develop demonstrator. It will be experiment on ground, so we try to acquire a license to use it. And we will do outreach to the public and stakeholders. Finally, our project goals are clarifying the non-technical barriers and their countermeasures.
Last page shows our project goals. Our project goal is 3 points. We will propose how to sell the microwave and promote frequency assignment for SPS and raise awareness of SPS international problem. So we are looking forward to present in Dubai. Thank you for listening.
Hello, my name is Nimsha, and I will be presenting the novel approach to space-based solar power system design with a focus on life cycle CO2 challenges proposed by our team, Orizuro. First, we'll be going over energy overview, followed by space-based solar power. Then, I will explain the design and functionality of our proposed solution, followed by its life cycle assessment, and we'll be concluding today's presentation with future steps of this project. Energy drives economies and sustains societies, and makes a vital contribution to people's quality of life. With that being said, more than 1 billion people still lack access to electricity, while the rest heavily rely on fossil fuels to supply their energy demand. The motivation for this project is to reduce our reliance on fossil fuels to supply energy, while making reliable, accessible, and clean energy available to everyone on the planet. Global energy demand is rising due to economic development, increasing population, and technological developments. Fossil fuels are the main source of energy supply, but they are not sustainable. In addition, burning fossil fuels to produce power emits several air pollutants that are harmful to both the environment as well as public health. In fact, energy consumption and production is the biggest contributor to global warming. For instance, in the United States, about 25% of global warming emissions are solely due to electricity production. Most of those emissions come from fossil fuels like coal and natural gas. Considering that fossil fuels are a finite resource and produce large quantities of carbon dioxide when burned, it is important to seek alternative sources of energy. Recently, increasing attention has been paid to cleaner sources of energy such as nuclear energy, hydropower, wind power, and terrestrial solar energy. Although these sources are less carbon intensive, they have implications associated with them in terms of land use, environmental impacts, efficiency, intermittency, and human factors. For instance, nuclear and wind power both require high infrastructure investment and cannot be built and accessed everywhere in the world. In addition, nuclear energy has high density waste and risks of radiation and proliferation. On the other hand, terrestrial solar PVs are easier and less costly to implement, but due to their nature of intermittency, they are unreliable sources of energy supply. The comparison becomes clear when we look at the numbers here. As we saw in the previous slide, some sources of energy are clean but less efficient and unreliable. And those that are efficient tend to be harmful for the environment and expensive to implement. The best proposed solution to supply energy is one that does not have the harmful impacts of fossil fuel, but at the same time provides continuous power. Space-based solar power provides continuous energy while minimizing carbon emissions and other harmful environmental impacts. This concept came into the industry to overcome the drawbacks of ground-based solar power. Advantages of SBSP concept are 100% availability of solar energy, 40 times more energy production than terrestrial solar power, comparatively small land is required for them, zero effects on natural habitats, controlling CO2 emissions by using liquid propellant rockets to launch. We are planning to launch the Orizuru satellite to geostationary orbit to achieve global coverage by minimizing collision risks. Another advantage of GEO is that it needs only 3 to 4 satellites to cover the globe. We are proposing a modified design of flasher origami shape for solar panels, as its compliant mechanism makes this design easy to implement, and it also reduces the payload size for launching vehicle. The Orizuru satellite solar panels will have a coating of convex lenses over photovoltaic cells. These lenses will optimize the intensity of incoming solar light, resulting in the increased efficiency of solar panels. Traditionally, silicon has been the first choice for solar panels by taking the cost factor into consideration, while we also want to evaluate the performance of gallium arsenide for SBSP project, as they have higher efficiency and degrade more slowly than silicon in the space radiation environment. As various models are already working on 2.5 and 5.8 GHz frequencies, we will be studying the model with an 8.5 GHz transmitting frequency to increase the transmitting efficiency by reducing the size of transmitting antenna at the same time. The efficiency of the existing model is around 9.6%, and with our design, we are targeting to achieve an efficiency of around 15%. In this project, we will be considering the projection of electricity demand and conduct a life cycle assessment to determine the extent to which SBSP technology is feasible. The life cycle assessment will take a detailed approach in analyzing the CO2 emission from 5 main stages: material extraction, manufacturing and processing, transportation, usage, waste disposal, and end of life. We will be optimizing the suggested design to improve the output of the SBSP system by making the structure more stable. This will decrease the levelized cost of electricity lesser than $2 per kilowatt hour. In the future, we are planning to take this idea to the next level, where the Orizuru will power up satellites in further orbits with an altitude of 40,000 to 42,000 kilometers. Thank you for listening.